There are places on this planet where logic falters, where evidence ends and questions multiply. Deep beneath the sands, frozen in ice, or hidden within ancient ruins, lie puzzles that refuse to yield their secrets. Scientists have studied them for decades, armed with satellites, DNA sequencing, and quantum mathematics. Yet some mysteries remain as impenetrable as the day they were discovered. From strange signals echoing across the cosmos to impossible ancient structures carved with precision beyond their time. From eerie geological anomalies to living creatures that defy the laws of evolution. Each of these enigmas pushes the limits of what we know about our world and ourselves. Are these simply gaps in our understanding, or clues to something far greater, woven into the very fabric of nature? Tonight, we journey across continents and centuries to confront the mysteries science still cannot solve. So sit back, relax, and let's dive deep into the unexplained. In the cold silence of deep space, where stars burn like scattered embers across an endless void, there exists a presence that cannot be seen, touched, or measured by any ordinary means. It surrounds every galaxy, binds clusters of stars together, and weaves through the universe like an invisible web. Yet it gives off no light, emits no heat, and interacts with matter only through gravity. Scientists call it dark matter, a name that reveals both our awareness of it and our ignorance of what it truly is. The story of dark matter begins, fittingly, with an observation that didn't quite add up. In the 1930s, the Swiss astronomer Fritz Zwicky was studying the Coma Cluster, a massive collection of galaxies nearly 300 million light-years away. As he measured their motion, he noticed something strange. The galaxies were moving far too fast. By all visible accounts, they should have flown apart, scattered into the emptiness. But they didn't. Something unseen was holding them together, exerting a gravitational pull strong enough to keep the cluster intact. Zwicky called this hidden substance dunkle materie, dark matter. Few took him seriously at the time. Yet decades later, the mystery he uncovered would shake the foundations of cosmology. By the late 20th century, astronomers using advanced telescopes and radio instruments began mapping galaxies with unprecedented precision. The same puzzle emerged again and again. Stars at the outer edges of spiral galaxies orbited at speeds that defied Newtonian physics. The visible mass, gas, dust, stars, wasn't nearly enough to account for the gravity holding them in place. The only explanation, it seemed, was that something else, vast and unseen, was shaping the cosmic structure. Today, scientists estimate that dark matter makes up roughly 27% of the universe. Everything we can see, planets, stars, nebulae, and galaxies, accounts for less than 5%. The rest is invisible. And even more perplexing, dark matter is only half the mystery. The remaining 68% of the universe appears to be made of something even stranger: dark energy, a mysterious force driving the accelerating expansion of space itself. In 1998, two independent teams of astronomers studying distant supernovae discovered that the universe's expansion was speeding up, not slowing down as expected. It was as if some unknown energy were pushing galaxies apart with a force stronger than gravity itself. No one could explain it. The term dark energy was coined, not to describe its nature, but simply to mark the boundaries of our ignorance. Scientists have proposed many theories to explain these invisible forces. Some believe dark matter consists of exotic particles, WIMPs, or weakly interacting massive particles, that barely interact with ordinary matter. Others suggest it might be made of sterile neutrinos, or even primordial black holes left over from the dawn of time. More radical ideas propose that dark matter isn't a substance at all, but a sign that our understanding of gravity is incomplete. That perhaps Einstein's equations, for all their beauty, are missing a hidden layer of reality. Dark energy is even more elusive. Some physicists describe it as a property of space itself, a built-in pressure known as the cosmological constant. Others imagine it as a dynamic field that ebbs and flows over time, subtly changing the fate of the cosmos. A few fringe theorists speculate that dark energy could be linked to parallel universes or higher dimensions, echoes of unseen realities pressing against our own. And yet, despite decades of research and countless experiments, dark matter and dark energy remain unobserved directly. Deep underground, in laboratories shielded from cosmic radiation, detectors sit in perfect silence, waiting for the faintest sign of a particle that may never come. High above, the James Webb Space Telescope peers into the oldest light of the universe, searching for patterns that might hint at the invisible scaffolding beneath. The deeper we look, the stranger it becomes. Computer simulations reveal that dark matter forms intricate, web-like filaments stretching across the cosmos, connecting galaxies in vast cosmic highways. It is within these filaments that galaxies are born, drawn together by gravity like dew forming on invisible strands. And yet, we have never seen it. We only infer its existence from what it touches, from the bending of light, from the motions of stars, from the whispers of gravity in the dark. If dark matter binds the universe, dark energy seems to be tearing it apart. Over billions of years, its mysterious pressure grows stronger, pushing galaxies farther from one another. One day, perhaps trillions of years from now, this accelerating expansion could scatter even atoms beyond reach, leaving a universe cold, empty, and forever silent. But for now, we live in a fleeting moment between forces we cannot see. Every particle of our existence moves through an ocean of the unknown. What is this darkness that shapes the cosmos? Is it matter beyond our comprehension or evidence of laws not yet written? Could it hold the key to understanding the origin and ultimate fate of everything? For all our equations and instruments, the universe still keeps its deepest secrets. Somewhere, in that vast and silent night, the truth waits to be found. As the search for dark matter and dark energy continues to stretch the boundaries of our understanding, another cosmic enigma pulses through the silence of the universe, brief, powerful, and utterly mysterious. These are fast radio bursts, or FRBS, intense flashes of radio waves that last no more than a few milliseconds, yet release more energy than our sun emits in days. They arrive without warning, from random corners of the cosmos, like whispers from something vast and unseen. It began quietly, almost by accident. In 2007, while analyzing archived data from the Parkes Observatory in Australia, astrophysicist Duncan Lorimer and his student stumbled upon something unexpected: a single, extraordinarily bright radio signal that appeared to have traveled billions of light years before reaching Earth. It lasted just 5 milliseconds. No telescope had ever recorded anything quite like it. The signal didn't match any known cosmic event, and it wasn't repeating. For a moment, it seemed to come from nowhere and vanish into nothing. At first, many dismissed it as an error, a stray signal, a glitch, perhaps interference from human technology. But then, more appeared. From Canada, Puerto Rico, and Chile, observatories began detecting similar bursts, short, powerful flashes that originated far beyond our galaxy. Each carried the same fingerprint, a dispersion pattern consistent with traveling through vast stretches of intergalactic plasma. These were not local signals. They were cosmic in scale. The pattern of discovery was strange, Some bursts appeared only once and never again, while others repeated at irregular intervals. One, known as FRB121102, became the first to pulse repeatedly from the same location, a small, star-forming galaxy 3 billion light-years away. Unlike anything seen before, it seemed to be sending messages in rhythm, then falling silent for weeks, sometimes months, before bursting again. The repetition ruled out one-time cataclysms like supernovae, but it raised even deeper questions. What kind of object could produce such powerful, precise emissions, yet remain invisible to our eyes? Scientists began to search for natural explanations. One leading theory points to magnetars, ultra-dense neutron stars with magnetic fields billions of times stronger than Earth's. When their crusts shift or fracture, they release immense energy, enough to generate radio bursts of staggering intensity. In 2020, this theory gained weight when an FRB-like signal was detected from within our own Milky Way, seemingly linked to a known magnetar. Yet, not all FRBs fit this model. Some bursts repeat in patterns too complex or consistent to be random. Others appear to originate from regions of space devoid of visible galaxies. Alternative ideas emerged. Could these signals be connected to black holes, perhaps the flicker of matter falling into their gravitational maw, or collisions between exotic cosmic remnants? Some propose that FRBs might be the final cry of collapsing stars, or energy released during the birth of new ones. Others wondered if we might be witnessing the signature of something even more profound, phenomena not yet recognized by physics, or the faint trace of advanced technologies far beyond our own. The notion of artificial origin, though often treated cautiously, has persisted on the fringes of the debate. After all, the universe is filled with electromagnetic noise from pulsars, quasars, and distant galaxies, and yet FRBs stand apart for their sudden precision and inexplicable power. Could they, in some unfathomable way, be signals, intentional or not, from civilizations scattered across the cosmic deep? Most scientists remain skeptical, but even the skeptics admit the possibility cannot be entirely ruled out. Meanwhile, instruments have grown more sensitive, and detections more frequent. New telescopes, like CHIME in Canada and ASCAP in Australia, now record hundreds of FRBs every year. The once rare phenomenon has become almost commonplace, yet no two are exactly alike. Some come in tight clusters, others in rhythmic patterns, some flashing with clockwork regularity, as if following cycles we do not yet understand. A few even seem to originate from magnetic environments so extreme that our current models strain to explain them. Each discovery deepens the mystery rather than resolves it. We now know that FRBs are scattered across the universe, perhaps numbering in the thousands each day, occurring even now, somewhere out there, in the great darkness between galaxies. They travel for billions of years, crossing cosmic filaments and voids, to reach the small blue planet where we listen. Yet despite all our instruments and theories, their origin remains a question suspended in the dark. Suspended in what mechanism can unleash such immense power in an instant, yet leave no trace behind? Are we hearing the chaotic echoes of the universe itself, its magnetic storms and dying stars, or something deliberate, structured, waiting to be recognized? For now, the signals continue to arrive, scattered like Morse code across the stars. Each one carries a message we do not yet understand, written in a language older than humanity. And as our instruments grow sharper, our data richer, we find ourselves drawn ever deeper into the enigma, wondering what or who might be speaking across the silence of time and space. The radio signals from distant galaxies still echo faintly through the void, their origins uncertain. But beyond those bursts of invisible energy lies an even deeper question, one that has haunted astronomers, philosophers, and dreamers for generations. If the universe is filled with stars, planets, and the building blocks of life, then where is everybody? It's a question that sits at the very heart of one of the greatest cosmic mysteries of all time, the Fermi Paradox. Imagine a quiet summer afternoon in 1950. The setting is Los Alamos National Laboratory in New Mexico, a place where some of the brightest minds in physics gather to discuss the possibilities of life beyond Earth. Among them is the Italian physicist Enrico Fermi, the man who helped unlock the power of the atom. During a casual lunchtime conversation about UFOs and the potential for interstellar civilizations, Fermi suddenly pauses, frowning. Then, almost to himself, he asks, "Where is everybody?" It was a simple question, but it carried profound implications. By then, scientists already knew that our galaxy alone contained hundreds of billions of stars. Many of those stars are older than the Sun, and countless are surrounded by planets. If even a small fraction of those planets could host life, and if even a fraction of that life evolved into intelligent civilizations, then the Milky Way should be teeming with activity, colonized worlds, radio signals, artifacts drifting through space. Yet, despite decades of searching, we have found nothing. No signals, no probes, no signs of ancient visitors. Just silence. The contradiction between the high probability of extraterrestrial life and the lack of evidence for it became known as the Fermi Paradox. It is both a scientific puzzle and a philosophical mirror, forcing humanity to confront its place in the cosmos. Over the years, scientists have proposed countless solutions. Some are grounded in physics and biology, others stretch the imagination. One explanation suggests that intelligent life is exceedingly rare, that the emergence of consciousness requires such a delicate balance of conditions that we may in fact be alone. Another argues that life might be common, but short-lived, that civilizations tend to destroy themselves before they can reach beyond their home worlds. Nuclear war, environmental collapse, or artificial intelligence could all serve as self-inflicted ends. Others look to the vast distances between stars. Even with technology far beyond our own, interstellar travel may be prohibitively slow or dangerous. Perhaps civilizations simply never leave their planetary systems. Or maybe they don't want to. There's also the unsettling idea known as the Great Filter, the notion that somewhere along the path from simple life to spacefaring intelligence lies a nearly impossible barrier. If that barrier is behind us, humanity may be among the lucky few to survive it. But if it lies ahead, our future may be far shorter than we imagine. And yet, other theories shift the question entirely. What if the galaxy is full of life, but we simply haven't recognized it? Some suggest that extraterrestrial civilizations could exist on a scale or form beyond our comprehension. Perhaps they communicate not through radio waves, but through methods that transcend our current understanding of physics. Others speculate that they might exist in virtual realities, having abandoned the physical universe altogether. There is also the possibility, haunting in its simplicity, that advanced civilizations choose not to reveal themselves. This is the essence of the zoo hypothesis, that humanity is being deliberately observed, perhaps protected, or even quarantined until it reaches a certain level of maturity. In this view, the silence of the stars is not evidence of absence, but of restraint. More speculative thinkers have even wondered if the paradox itself is an illusion. If our reality is a simulation, an artificial construct designed for observation or experience, then perhaps the reason we find no others is because the simulation was never programmed to include them. Despite the allure of these ideas, science continues its patient search for answers. Radio telescopes scan the skies for artificial signals through projects like SETI, the search for extraterrestrial intelligence. The Kepler and TESS missions have confirmed thousands of exoplanets, many within the so-called habitable zone. And yet, the cosmic silence remains unbroken. Still, the question persists, growing more urgent with every discovery of a new Earth-like world. Could intelligent life exist out there, simply too distant for us to detect? Or are we truly alone, a singular spark of awareness adrift in an indifferent universe? Perhaps the answer lies not in the stars, but in our own limitations. We listen with human instruments, search with human expectations, and interpret the universe through human logic. If other minds exist, they may be so different from us that we would not even recognize their presence. For now, the paradox endures. The Milky Way stretches silently across the night sky, its billions of suns burning with quiet indifference. Somewhere, perhaps, there are others looking up, wondering the same thing. If life is as resilient and abundant as we believe, then the silence of the cosmos is not just puzzling, it's haunting. So we keep listening, because the answer, whatever it may be, will change everything we think we know about the universe and about ourselves. Far beyond the planets, past the orbit of Neptune, in the cold and lonely expanse of the outer solar system, two silent travelers glide through the void. The spacecraft Pioneer 10 and Pioneer 11 were launched in the early 1970s, designed to explore the outer planets and then continue into interstellar space, a bold testament to human ingenuity. Their journeys would take them farther than any human-made object had ever gone, carrying not only instruments and data, but a small golden message intended for any civilization that might encounter them. For years, the pioneers sent back remarkable information about Jupiter, Saturn, and the fringes of the solar system. But as they ventured beyond the known planets, something curious began to appear. Precision tracking revealed a tiny, persistent deviation from their expected paths. Both spacecraft appeared to be slowing down slightly, ever so gradually, as if an invisible hand were tugging on them from the dark reaches of space. The effect was subtle, barely detectable, but unmistakable. Scientists dubbed it the Pioneer Anomaly. Initially, it seemed plausible that the cause was mundane. Perhaps it was heat from the spacecraft itself, radiating unevenly into space and creating a gentle thrust. Or maybe minor gas leaks, imperfections in the trajectory calculations, or gravitational influences from distant objects could explain the phenomenon. Yet, after decades of analysis, the anomaly stubbornly resisted explanation. The effect persisted over millions of kilometers, measurable and consistent, yet unexplained. The Pioneer Anomaly raised questions that went far beyond the mechanics of two spacecraft. Could it hint at a flaw in our understanding of gravity? A subtle distortion in the fabric of space-time itself, invisible yet powerful enough to nudge a spacecraft off course? Some physicists considered whether dark matter within the solar system, or unknown interactions with interplanetary dust, might play a role. Others speculated that the anomaly could be evidence of new physics, forces or effects that conventional theories had yet to predict. The anomaly is fascinating not only for its mystery but for its silence. Unlike the loud and sudden signals of fast radio bursts, this effect whispers slowly across the void, detectable only through painstaking measurement and calculation. It reminds us that space is not simply empty, but a realm of subtle forces, of tiny nudges and invisible currents that we are only beginning to perceive. Over the years, some proposed even more speculative ideas. Could the Pioneer Anomaly be evidence of extra dimensions, tiny leaks from parallel universes, or a previously unrecognized property of gravity at extreme distances? Some have wondered whether the effect might be an echo of something larger, an unknown structure in the cosmos influencing our solar system, or even the faint signature of civilizations manipulating the fabric of space. While these notions remain on the fringes of scientific discourse, they underscore the profound uncertainty and awe that accompany this quiet mystery. Remarkably, the anomaly persisted for both Pioneer spacecraft, despite their different launch trajectories and histories, suggesting that it is not simply a quirk of a single craft. Engineers and astrophysicists re-examined every detail: telemetry, onboard heat sources, even the way radio signals themselves were reflected and measured across billions of kilometers. Each analysis brought insight, yet no definitive answer emerged. The Pioneer Anomaly is a reminder of the vast unknowns that lie even within our own cosmic backyard. Here, in the space between planets and stars, our models are tested and our assumptions challenged. The spacecraft, now silent and drifting, continue their journey into interstellar space, carrying with them not only the hopes of early explorers, but the persistent question of why the universe behaves in ways we cannot fully predict. What could account for this subtle, unrelenting deviation? Is it a simple artifact of engineering, or a doorway into physics we have yet to understand? Could the anomaly be a gentle whisper of forces that stretch across the solar system, invisible to the eye yet capable of guiding human-made objects with uncanny precision? As Pioneer 10 and 11 continue their eternal drift, moving silently through the cosmic dark, the mystery follows them. We can track their path with exquisite accuracy, yet the reason for their slight, inexorable deceleration remains unknown. Perhaps it is a subtle clue to a deeper truth about the universe, waiting for the next generation of scientists to decipher. Or perhaps it is a reminder of how little we truly know, even in the familiar space of our own celestial neighborhood. The anomaly persists, quiet, patient, and inexplicable, a cosmic puzzle drifting among the stars, inviting us to wonder what other secrets the universe has yet to reveal. Far beyond the orbit of Neptune, in the vast darkness where the sun's light dwindles into a faint glow, an interstellar traveler raced through the solar system, a visitor from another star, moving faster and more erratically than any known object bound by our sun's gravity. In October 2017, astronomers at the Pan-STARRS telescope in Hawaii detected it for the first time. They named it Oumuamua, a Hawaiian term meaning scout or messenger, a fitting name for an object that seemed to arrive from nowhere, only to vanish almost as quickly. Unlike the comets and asteroids that populate our solar system, Oumuamua defied expectations. Its shape was extraordinary, highly elongated, perhaps 10 times longer than it was wide, with sharp edges catching sunlight in ways that suggested a tumbling, irregular rotation. Its surface appeared dark and reddish, coated in cosmic radiation from its journey across interstellar space. From the very first observations, scientists realized they were witnessing something unprecedented. The first confirmed object to pass through our solar system from another star. Yet even as telescopes tracked its trajectory, new mysteries emerged. Oumuamua's speed and path did not conform entirely to what gravity alone would dictate. As it slipped past the sun, it exhibited a subtle acceleration, slightly faster than expected, without any visible outgassing or comet-like tail. This faint, unexplained push defied conventional models. Was it venting gas too faint to detect? Or was something else at work, forces we had never accounted for? Mainstream science has largely treated Oumuamua as a natural object, perhaps an elongated fragment ejected from a distant planetary system, shaped by collisions and cosmic forces over millions of years. Its interstellar origin is certain, its composition likely a mix of rock and metal, perhaps coated with frozen volatiles stripped away during its passage. Yet these explanations, while plausible, leave questions unanswered. Its unusual shape, its spin, and its mysterious acceleration resist easy categorization. Speculative theories soon followed. Some scientists, intrigued by the unusual acceleration and the perfect trajectory past the Sun, have proposed that Oumuamua might be a form of artificial object, a probe or light sail propelled by radiation pressure sent intentionally across the stars. These ideas remain on the fringe of scientific consensus, but they highlight how little we truly know about the forces shaping small objects in interstellar space and how an unfamiliar visitor can challenge our understanding. Even the simplest features of Oumuamua are difficult to reconcile with known categories. Unlike comets, it left no detectable gas or dust behind. Unlike asteroids, its shape is extreme, its brightness variations dramatic. As it tumbled through the solar system at tens of kilometers per second, it seemed almost deliberately evasive, appearing in our telescopes for mere weeks before continuing its journey back into the cosmic dark. Observations revealed further peculiarities. Its rotation seemed chaotic, not spinning smoothly like most small bodies in our solar system. The changes in brightness implied an elongated, perhaps cigar-shaped form, though some models suggest it might be more like a flattened disk or pancake. Each model fits some aspects of the data but contradicts others, leaving astronomers grappling with a puzzle they may never fully solve. The discovery of Oumuamua forced scientists to confront the possibility that our solar system is far more permeable than previously imagined. Interstellar objects might be passing through regularly, unnoticed, carrying clues to the conditions, histories, and architectures of other star systems. If one could reach us, what might it tell us about distant worlds? And what else, invisible and fleeting, might have passed undetected before or may come again? Ultimately, Oumuamua remains an enigma. It arrived from the stars, glimmering briefly in the sunlight, offering more questions than answers. Its sudden acceleration, extreme shape, and interstellar origin hint at processes and histories far beyond our solar system, yet every detail remains tantalizingly out of reach. Was it merely a fragment of a distant world, ejected by planetary collisions? Or could it be something more? An emissary from another civilization or a natural object behaving in ways we do not yet understand? As it continues its journey into the depths of space, Oumuamua disappears into the darkness, leaving behind only the faintest trail of light and a lingering question. How many other mysteries are drifting unseen through the vastness of the cosmos, waiting for us to notice them? And among them, could there be something that challenges not just our understanding, but our very place in the universe? Far beyond the familiar constellations, beyond the reach of the naked eye, lies a subtle imprint on the cosmos itself, an enigmatic feature of the very fabric of the universe. When scientists examine the oldest light we can observe, the cosmic microwave background, patterns emerge that both intrigue and unsettle. Among them, a mysterious alignment of temperature fluctuations stretches across the sky, an unexpected preference in directionality that seems to defy the very principle of isotropy, the idea that the universe should look roughly the same in all directions. This feature has been dubbed the axis of evil. The story begins with the Wilkinson Microwave Anisotropy Probe, or WMAP, launched in 2001 to map the cosmic microwave background with unprecedented precision. As researchers sifted through the data, they noticed something strange. Certain large-scale fluctuations, the quadrupole and octupole modes, appeared unusually aligned along a single axis in space. While the universe is supposed to be random at these scales, these patterns suggested a subtle directional preference, as if the cosmos had a hidden orientation. It was unexpected, puzzling, and deeply controversial. Mainstream cosmology offers explanations grounded in known physics. Perhaps the alignment is simply a statistical fluke, a coincidence arising from the small number of observable large-scale modes. Others have suggested subtle instrumental biases or interference from local sources, such as foreground emissions from our own galaxy. Yet, despite careful cross-checking and new data from the Planck satellite, the anomaly persists. It remains one of the most compelling hints that our universe may harbor features that current models cannot fully explain. The term axis of evil, though evocative, reflects the unease it provoked within the scientific community. Could such a cosmic alignment hint at new physics? Some theorists have speculated that it could indicate large-scale anisotropies, unseen structures stretching across the universe, or a more complex topology than the standard cosmological model suggests. Might the universe itself have a preferred direction, a subtle bias embedded in its very expansion? If so, it challenges the foundational assumption that the cosmos is uniform and directionless on the largest scales. Other, more speculative ideas have emerged. Some have wondered whether the axis could be the fingerprint of a multiverse, a signal from neighboring universes subtly influencing our own. Could gravitational interactions from distant regions beyond our observable horizon leave traces in the microwave background, guiding these alignments? And what if the patterns point to physics that has been overlooked, a property of space-time itself that reveals hidden layers of reality waiting to be discovered? The axis of evil also evokes philosophical questions. In a universe vast beyond comprehension, filled with billions of galaxies and countless stars, what does it mean if there is a preferred direction? Could this axis be a message, unintentional or otherwise, imprinted at the birth of the cosmos? Or is it a natural outcome of processes we have yet to fully understand, chaotic, elegant, and unknowable? Some scientists urge caution. The universe is complex, and patterns can emerge where none truly exist. But the anomaly persists across multiple datasets and analytical methods. It has survived scrutiny and remains robust enough to command attention, forcing cosmologists to acknowledge that the universe may hold secrets not anticipated in existing theories. What makes the axis of evil particularly haunting is its scale. Unlike localized cosmic phenomena, black holes, neutron stars, or galactic collisions, this alignment extends across billions of light-years, tracing a pattern that spans the observable universe. It is a subtle, yet persistent reminder that the cosmos is not entirely random, that large-scale features may be written into its earliest moments, waiting for us to detect them. The discovery invites reflection. What other hidden structures might exist beyond our perception? Are there patterns in space-time yet to be revealed by future observations? Subtle imprints from the very birth of the universe that hint at a deeper order? And if the axis of evil is more than coincidence, what does it tell us about the origin, evolution, and ultimate fate of everything we see? For now, the alignment remains a silent enigma, a quiet signal woven into the oldest light in the universe. It reminds us that even in the vast emptiness between galaxies, the cosmos may be more structured, more mysterious, and more alive with unanswered questions than we can imagine. As astronomers continue to scan the skies, refining measurements and probing the cosmic microwave background with ever greater precision, the axis of evil endures, a ghostly whisper of the universe's hidden geometry, inviting us to wonder how much of the cosmos is still beyond our grasp, and what other cosmic truths are waiting silently in the darkness. Far above the plains of Ohio, where the night sky stretches dark and endless, the Big Ear radio telescope quietly scanned the heavens in the summer of 1977. Its antennas swept across the stars, listening intently for faint whispers that might travel across light years, seeking signals that could reveal life beyond our planet. On the evening of August 15th, amidst the usual hum of cosmic background noise, the telescope recorded something extraordinary, a signal unlike anything that had been detected before. It was narrow, intense, and brief, lasting just 72 seconds, yet it stood out like a beacon against the vast, uniform background of space. Astronomer Jerry Amon, examining the printout in his office, circled the entry in red pen and scrawled a single word in the margin. Wow. Thus, the famous wow signal entered the annals of scientific mystery, a fleeting, inexplicable pulse from the depths of the cosmos. The signal's origin was traced to a region near the constellation Sagittarius, in the direction of the Sagittarius Stream, a dense band of stars and interstellar matter. Its frequency, close to 1,420 megahertz, the so-called hydrogen line, a natural emission frequency of neutral hydrogen, suggested that it could have been deliberately chosen, perhaps even by an intelligent source aware that hydrogen is the most abundant element in the universe. The more scientists examined it, the more tantalizing it became. It seemed almost too perfect to be random, yet its sudden appearance and disappearance left no trace behind. Natural explanations were considered first. Could it have been a reflection from a passing comet or an unknown astronomical object? Interference from satellites, terrestrial radio, or even military transmissions was scrutinized. Every alternative was analyzed, every hypothesis tested. And yet, no conventional source could convincingly reproduce the signal. Unlike other radio emissions, which can often be traced and predicted, the WOW signal defied classification. Its singularity deepens the mystery. Despite numerous follow-up observations by Big Ear and other radio telescopes around the world, the signal was never detected again. It arrived once, with a sharp rise and fall in intensity, then vanished, leaving astronomers and enthusiasts alike in a state of perpetual curiosity. What could send such a powerful, yet fleeting signal across interstellar space, only to vanish without a trace? Speculative theories soon entered the conversation. Could the signal have been evidence of extraterrestrial intelligence, a purposeful broadcast or beacon aimed across the stars? Some researchers have suggested that the hydrogen line's significance might make it a universal hailing frequency, a cosmic standard understood by any technologically advanced civilization. Others propose more exotic natural explanations, including unknown plasma phenomena, rotating neutron stars, or transient emissions from distant cosmic sources that behave unlike anything previously observed. The WOW signal is as much a philosophical enigma as it is a scientific one. It challenges our assumptions about the universe's quietude, reminding us that even in the vast emptiness between stars, there may be activity that escapes our understanding. It hints at the possibility that the universe is not a silent, indifferent void, but a realm that might be communicating in ways subtle, fleeting, and profoundly mysterious. Yet, for all its intrigue, the signal remains frustratingly elusive. Even decades of technological advancement, sophisticated telescopes, and continuous monitoring have not yielded a second wow. There is no repeatable data, no pattern to analyze, no context beyond the singular moment when it appeared. It is a cosmic message in a bottle, drifting silently through time and space, leaving only questions in its wake. Could the WOW signal have been the faint whisper of another civilization, reaching across unimaginable distances to announce its presence? Or was it a natural phenomenon that behaves in ways we have yet to comprehend? A brief flicker in the ocean of the universe, extraordinary precisely because it is so rare? Perhaps we will never know, and perhaps that is part of its allure. A reminder that the cosmos is more intricate, more unpredictable, and more mysterious than even our most sensitive instruments can reveal. For now, the WOW signal endures as both a challenge and a temptation. It asks us to listen more carefully, to explore more boldly, and to confront the possibility that the universe may hold messages beyond our comprehension, waiting for the moment when we are ready to receive them. Somewhere, far beyond our solar system, that single pulse remains, a fleeting mark on the canvas of space and time, inviting us to wonder, what else is out there, sending quiet signals across the darkness, and how many mysteries of the cosmos are still waiting to be discovered. Far above the rings and swirling clouds of Saturn, a vast and mysterious structure hovers over the planet's north pole. Viewed from the Cassini spacecraft and earlier by the Voyager missions, it is unlike anything seen elsewhere in the solar system. A persistent, sharply defined hexagon, an enormous six-sided jet stream, hundreds of kilometers across, encircling the planet's polar vortex. Its edges are straight and precise, cutting through the swirling clouds with a geometric perfection that seems almost deliberate, as if the planet itself were inscribing a cosmic signature upon its atmosphere. The first glimpses of this phenomenon came from Voyager 1 and 2 in the early 1980s. Scientists were struck by its strange symmetry, a shape so regular and enduring that it defied expectations of chaotic planetary weather. Unlike the turbulent storms and irregular bands that dominate Saturn's atmosphere, this hexagonal jet stream rotates steadily, maintaining its form year after year, decade after decade. Subsequent observations by the Cassini mission confirmed that the hexagon is massive, about 29,000 kilometers across, large enough to contain 4 Earths within its boundaries. The hexagon's color is equally enigmatic. Seasonal changes bring subtle shifts in hue, from pale blue to golden brown, hinting at complex chemical reactions in the upper atmosphere. Its interior is a swirling maelstrom of winds, reaching speeds of over 320 kilometers per hour, yet somehow the six-sided boundary remains unbroken. How can such an ordered, geometric shape persist in the midst of turbulent planetary weather? Why does Saturn, among all the planets, produce such a phenomenon? Mainstream explanations point to fluid dynamics and the principles of atmospheric physics. Laboratory experiments with rotating fluids have shown that hexagonal patterns can arise when a fluid moves at different speeds at varying latitudes, generating standing wave patterns that stabilize into polygons. The hexagon may be a massive manifestation of this effect, scaled up to planetary proportions. Yet, even with these models, the precise stability, the clarity of the edges, and the longevity of the structure remain difficult to fully explain. Most terrestrial analogs last only minutes or hours, whereas Saturn's hexagon has persisted for decades. Speculative theories have emerged to account for the oddities of this cosmic geometric feature. Some researchers wonder whether magnetic fields or subtle interactions with Saturn's interior could play a role, guiding the formation of the pattern and locking it in place. Others suggest that the hexagon may be a visible expression of deeper hidden dynamics within the planet, waves of energy moving from the core outward, shaping the atmosphere in ways we cannot directly observe. The hexagon also invites broader philosophical reflections. In a universe often perceived as chaotic, the sudden appearance of perfect geometric order challenges our assumptions about natural patterns. Could Saturn's hexagon be a reminder that order and symmetry can emerge spontaneously, even in systems as vast and complex as planetary atmospheres? Or does it hint at physical processes that remain largely invisible? Subtle forces and interactions hidden beneath layers of clouds just beyond the reach of our instruments. One of the most haunting aspects of the hexagon is its persistence. Unlike storms on Jupiter, which erupt and dissipate over days or weeks, Saturn's polygon endures through seasons, through shifts in solar illumination, through the passage of decades. Its rotation is synchronous with the planet's interior, yet its formation mechanism is not fully understood. Scientists continue to debate whether the hexagon is maintained by the differential rotation of Saturn's atmosphere, by resonances in atmospheric waves, or by forces yet undiscovered. The hexagon is also a visual reminder of the scale and strangeness of the solar system. Seen from above, it is a geometric marvel, spinning silently against the backdrop of Saturn's cloud bands, its edges perfectly straight, its corners nearly sharp, and its interior a chaotic swirl of winds and vortices. It is a cosmic paradox, simultaneously orderly and turbulent, regular and unpredictable. As Cassini's cameras traced its edges in high resolution, capturing the hexagon's subtle color changes and turbulent interior, astronomers were left with more questions than answers. How did such a precise polygon form in the first place? How can it persist against the chaos of planetary weather? And why is it unique to Saturn, with no analogs on Jupiter, Uranus, or Neptune? The mystery of Saturn's hexagon endures, a geometric enigma suspended in the planet's northern skies. It is a reminder that even within our own solar system, there are natural phenomena that defy our understanding, that challenge the limits of physics and invite wonder. As we continue to study it, sending probes, analyzing data, and modeling planetary atmospheres, the hexagon remains a silent, spinning riddle, a polygonal signature etched into the clouds of a distant world, asking us to ponder the hidden forces and subtle patterns that shape the universe. What else might be lurking, unnoticed, in the turbulent atmospheres of other planets? And what truths might Saturn's hexagon reveal about the delicate balance of order and chaos in the cosmos? High above the thick, golden clouds of Venus, a planet often called Earth's twin, the sun's light filters through layers of acidic haze, scattering and dimming in strange and unpredictable ways. From orbit, the planet's upper atmosphere shimmers with motion, a roiling landscape of sulfuric clouds that conceal the scorching surface below. And yet, for decades, scientists have noticed something unusual within this dense, opaque veil. Mysterious absorbers, unknown substances that soak up sunlight in ways that cannot be fully explained. The story of Venus's unknown absorbers begins with early observations in the ultraviolet spectrum. As far back as the 1920s, astronomers peering through Earth-based telescopes noticed that Venus clouds reflected less ultraviolet light than expected. Certain regions appeared darker than others, hinting at uneven absorption across the planet. The phenomenon became more apparent with the arrival of spacecraft in the latter half of the 20th century. Missions like Mariner 10, Pioneer Venus, and later the European Space Agency's Venus Express mapped the planet in unprecedented detail, revealing an ultraviolet mystery. About half of the solar energy striking the upper clouds is absorbed, yet the responsible agent remained unidentified. Mainstream explanations have long pointed to sulfur compounds, particularly sulfur dioxide, as likely candidates. These molecules absorb ultraviolet light and are abundant in the planet's clouds, but models of their behavior fail to fully account for the observed absorption patterns. The distribution is uneven, the intensity fluctuates, and spectral measurements hint at wavelengths that sulfur compounds alone cannot explain. Something else is at work, something unseen, interacting with the sun's energy in ways we do not yet understand. The unknown absorbers are more than a scientific curiosity. They are a window into the planet's atmospheric dynamics and chemical processes. They influence the temperature structure, drive circulation patterns, and affect the mysterious superrotation of Venus's atmosphere, which causes winds at the cloud tops to circle the planet in just 4 Earth days. Understanding these absorbers could illuminate how Venus maintains such extreme conditions, and perhaps even reveal hints of active chemistry occurring high above the infernal surface. Speculative theories have emerged to account for the absorbers' puzzling properties. Some suggest exotic sulfur allotropes or complex chemical aerosols formed from photochemical reactions driven by intense solar radiation. Others consider metallic particles or even charged compounds that behave differently under Venus's dense, ionized upper atmosphere. More radical ideas, entertained by a few researchers, speculate that the absorbers could be biological in origin. Microbial life thriving in the temperate upper cloud layers, producing pigments that absorb ultraviolet light. While highly conjectural, these hypotheses highlight the degree to which Venus remains a world of extremes, where even its clouds resist easy explanation. Observations from orbiting spacecraft have revealed additional anomalies. The absorber's distribution is not uniform. Darker patches shift with altitude, latitude, and time, suggesting dynamic processes or perhaps wave-like atmospheric phenomena that are invisible from below. The interaction of sunlight with these layers also produces unexpected chemical reactions, hinting at a constantly changing, highly reactive environment. Each dataset deepens the mystery, suggesting that the absorbers are more than simple clouds. They are an active, enigmatic component of Venus's atmospheric machinery. Despite decades of study, the unknown absorbers remain unresolved. Their exact composition, origin, and behavior continue to elude scientists. New instruments, capable of measuring light in multiple wavelengths simultaneously, have provided tantalizing clues, but every discovery seems to raise further questions. Why does Venus, so similar in size and composition to Earth, host such a radically different atmosphere? Could the absorbers be remnants of volcanic activity, ancient processes frozen in time, or something entirely different? Chemistry we have yet to encounter elsewhere in the solar system. The mystery of Venus's absorbers is a reminder that even the planets closest to us hold secrets. While Earth has oceans and continents to explore, Venus hides its complexities behind a golden, acidic veil, accessible only through careful observation, sophisticated modeling, and daring space missions. The unknown absorbers are more than a puzzle. They are a testament to the layers of reality that remain hidden in even the most familiar worlds. As telescopes and probes continue to study Venus, the absorbers persist, silent and elusive, absorbing sunlight in ways we cannot yet fully interpret. They are a subtle whisper from the clouds, hinting at hidden processes, perhaps even phenomena entirely new to science. What is truly hidden within the golden haze of Venus? Could these absorbers reveal the planet's past, its present chemistry, or even the faint traces of life drifting in the clouds? The mystery remains, suspended in the thick, ultraviolet-rich skies, inviting us to look closer, think deeper, and wonder what else might be waiting to be discovered beyond the veil. Far across the cosmic void, where stars have long exhausted their nuclear fuel, lie some of the densest objects in the universe. Neutron stars. Born from the catastrophic collapse of massive stars, these remnants compress a sun's worth of mass into a sphere scarcely 20 kilometers across. Imagine the unimaginable. A teaspoon of neutron star matter would weigh billions of tons, so dense that atomic nuclei are crushed together, forming a state of matter that cannot be replicated on Earth. And yet, within these extraordinary celestial bodies, there exist subtle anomalies that have puzzled scientists for decades. Neutron star glitches. Neutron stars are often observed as pulsars, emitting beams of radiation from their magnetic poles like cosmic lighthouses. As they rotate, these beams sweep across space, producing remarkably precise pulses detectable on Earth. For years, astronomers marveled at their reliability, some pulsars rotating hundreds of times per second with clockwork regularity. But then, unexpectedly, certain pulsars would skip a beat. Without warning, the star's rotation would abruptly accelerate, a phenomenon known as a glitch. The first glitches were observed in the late 1960s, soon after the discovery of pulsars themselves. These sudden jumps in rotational speed were tiny in absolute terms, fractions of a second, but profound in their implications. They suggested that neutron stars, these hyperdense remnants of stellar collapse, were not entirely stable, that their interiors could undergo sudden shifts, releasing angular momentum in ways that defied straightforward explanation. Mainstream theories propose that glitches result from interactions within the star's interior. Beneath the rigid crust, a superfluid of neutrons may rotate independently of the outer layers. Over time, stress builds between the superfluid interior and the crust. When the stress exceeds a threshold, the crust may crack, or vortices in the superfluid may suddenly rearrange, transferring angular momentum and causing the star to spin slightly faster. This explanation aligns with many observations and provides a tantalizing window into exotic states of matter. Yet, even with these models, mysteries remain. Not all glitches fit neatly into expected patterns. Some occur too frequently, others too rarely, and a few are so large that they challenge conventional understanding of neutron star interiors. Why do some pulsars glitch regularly, while others, seemingly similar, remain perfectly steady for decades? How can a star, so rigidly bound by gravity and nuclear forces, release energy in such abrupt, unpredictable bursts? Speculative ideas have emerged alongside conventional theories. Some researchers wonder if glitches could signal phase transitions within the star's superdense core, shifts from one exotic state of matter to another, almost like seismic quakes on a cosmic scale. Others suggest that magnetic field instabilities, twisted and amplified by the star's rotation, might trigger sudden angular momentum transfers. A few fringe theories even consider interactions with dark matter, the invisible substance that permeates galaxies, as a subtle influence on these otherwise isolated stars. What makes neutron star glitches particularly compelling is their dual nature. They are both predictable and astonishingly unpredictable. They follow certain statistical patterns across populations of pulsars, yet each individual glitch carries its own signature, a unique fingerprint that resists easy categorization. They offer a rare glimpse into the internal physics of a star that is otherwise inaccessible to observation. Unlike surface phenomena, which can be imaged or spectroscopically analyzed, glitches betray the behavior of matter under pressures billions of times stronger than anything achievable on Earth. The timing of these events also raises profound questions. Some glitches are followed by a slow relaxation, as the pulsar gradually returns to its previous rotational rhythm over months or years. Others seem permanent, hinting at deeper, irreversible changes within the star. In each case, astronomers are forced to confront how matter behaves at the limits of density, pressure, and quantum mechanics, a realm that borders on the incomprehensible. Neutron star glitches are reminders that even the most extreme objects in the universe are not static. They are living, evolving systems, subject to forces and processes that challenge human understanding. Each glitch is a subtle tremor echoing from a core where gravity, quantum mechanics, and nuclear forces collide in ways we can scarcely imagine. As astronomers continue to monitor these cosmic lighthouses, waiting for the next unpredictable jump in rotation, the mystery endures. What exactly triggers each glitch? How does the superfluid interior communicate with the rigid crust? And what other phenomena, hidden deep within these collapsed stars, await discovery? For now, neutron star glitches remain one of the universe's quietest yet most profound enigmas. They are a reminder that even in objects defined by extreme regularity, the cosmos retains its capacity to surprise, to reveal secrets that stretch our understanding of physics and the very nature of matter. Somewhere in the vast darkness between the stars, a pulsar spins steadily, waiting for the next sudden, imperceptible shift, a glitch that will once again challenge our comprehension of the universe's most extreme realms. On a quiet summer morning in 1908, the remote Siberian taiga stretched endlessly under a pale, cloud-streaked sky. The air was still, the dense forest standing in solemn green silence, when suddenly, without warning, a blinding flash tore through the horizon. In an instant, the sky seemed to ignite. A colossal shockwave flattened trees across 2,000 square kilometers, sending shockwaves through the ground and the atmosphere, rattling windows hundreds of kilometers away. This was the Tunguska Explosion, a cataclysm so sudden, so immense, that it remains one of the most baffling events in modern history. Eyewitnesses described a fireball brighter than the sun, streaking across the sky with an eerie roar that shook the forest. Birds fell from the sky, and rivers churned as if stirred by unseen forces. Yet, when scientific expeditions finally reached the site years later, they found no conventional crater, no impact site as would be expected from a meteoric collision. The forest was flattened in a radial pattern, trees pointing outward like spokes of a wheel, but the ground bore no obvious scar from a buried object. The absence of a crater turned the explosion from a mere natural disaster into a scientific enigma. Mainstream explanations focus on a meteor or comet fragment disintegrating in the atmosphere, releasing an enormous burst of energy mid-air. Estimates suggest the explosion released energy equivalent to 10 to 15 megatons of TNT, hundreds of times more powerful than the Hiroshima bomb. Yet the exact nature of the object remains uncertain. Was it a stony asteroid, vaporizing before reaching the surface? Or a comet, rich in ice, disintegrating with almost no trace? Even with modern computer simulations and atmospheric models, no single theory fully accounts for the peculiar damage patterns, the absence of a crater, and the widespread environmental effects observed. Alternative theories have emerged to explain the Tunguska event, each attempting to grapple with the unknown. Some scientists have proposed a low-altitude airburst of a fragment from a comet or asteroid, but questions remain about the lack of meteoritic debris. Others have suggested a natural gas explosion, triggered by subterranean methane pockets released into the atmosphere, but the scale of the blast seems far beyond what gas alone could produce. Even more speculative hypotheses have surfaced over time. Miniature black holes passing through Earth, or unusual electromagnetic phenomena capable of releasing tremendous energy in a focused burst. While fringe, these ideas illustrate the enduring intrigue and the sense that something extraordinary occurred on that summer morning. The Tunguska Explosion also stands as a reminder of nature's raw and unpredictable power. Scientists studying tree rings found accelerated growth and scarring on nearby vegetation, suggesting the shockwave and heat altered biological systems long after the event. The atmosphere carried microscopic particles from the explosion, affecting sunsets and skies across Europe for months. The event was global in its resonance, yet localized in its epicenter, a singular phenomenon that defies simple explanation. Despite over a century of investigation, from Soviet-era expeditions to modern satellite analyses, questions linger. Why did no meteorite fragments survive? How could such an immense energy release occur entirely above the surface? And could events like Tunguska happen again anywhere on Earth without warning? Each answer uncovers new mysteries, revealing the limits of our understanding of celestial hazards and atmospheric physics. The Tunguska Explosion is not merely an isolated historical curiosity. It is a cautionary tale written in the trees and soil of the Siberian wilderness. It reminds us that Earth exists within a dynamic cosmic environment where even small objects from space can unleash devastation of unimaginable scale. Yet, for all its power, the event remains almost ghostly, a colossal force felt, seen, and recorded, but leaving behind only fragmented clues. What truly struck Siberia that morning? Was it a fragment of a comet, a small asteroid, or something even stranger, arriving from the depths of space to remind humanity of its vulnerability? The mystery endures, embedded in the flattened forests, in the accounts of witnesses, and in the lingering questions that have fascinated scientists for generations. As we look to the skies today, scanning for near-Earth objects and modeling potential impacts, the shadow of Tunguska lingers, an unanswered puzzle from the past, silently challenging us to comprehend the hidden forces that shape our planet and the universe beyond. What other phenomena might be occurring quietly above us, unseen, waiting to leave a mark on the Earth before vanishing into mystery once more? In quiet towns and rural landscapes across the globe, a strange phenomenon lingers at the edges of perception. It begins as a low, persistent hum, barely audible at first, yet impossible to ignore once noticed. Residents describe it as a constant droning, a vibration that seeps into walls, windows, and even the bones, a sound that seems to have no source, no pattern, and no explanation. This is known simply as the hum, a mysterious auditory experience reported from New Mexico to England, from Vancouver to parts of Australia, captivating scientists and ordinary people alike. The first modern reports date to the 1970s and 1980s, when communities began documenting complaints of sleepless nights, headaches, and a deep unease attributed to an untraceable sound. Some could hear it only indoors, others heard it outdoors. Attempts to measure the phenomenon with microphones and sensitive recording equipment often produced inconsistent results. In many cases, the hum appeared to be perceptible to some people but completely silent to others, a subjective experience that confounded early investigations. Mainstream science has offered several potential explanations. Industrial noise, low-frequency sound waves from distant machinery, and natural geophysical phenomena such as seismic vibrations or oceanic microseisms have all been proposed. Some researchers suggest that infrasound, sound waves below the threshold of human hearing, might interact with the inner ear, creating a sensation of a hum that is felt as much as heard. Yet in numerous documented cases, the apparent hum does not correspond with any identifiable external source. Measurements often detect no consistent environmental cause, leaving communities and researchers puzzled. The phenomenon becomes even more intriguing when considering its selective perception. Why do some people hear it while others do not? Could it be linked to individual sensitivity, variations in auditory processing, or perhaps even a subtle neurological response to environmental stimuli? In some regions, the hum seems to correlate with particular geological features, suggesting a possible link to subterranean activity, while in others, it appears in entirely different landscapes, leaving a pattern that is elusive and inconsistent. Speculative theories have emerged alongside conventional hypotheses. Some have proposed that the hum could originate from electromagnetic waves interacting with the nervous system, or even from mysterious industrial or military installations producing ultra-low-frequency vibrations. Fringe ideas extend further, suggesting that the hum could be a sign of Earth itself communicating subtle signals, or that it might be linked to previously unknown cosmic phenomena. While these notions remain unverified, they underscore the depth of uncertainty surrounding this enigmatic experience. What makes the hum so compelling is its intimacy. Unlike large-scale natural events or astronomical mysteries, it touches the daily lives of individuals. It disrupts sleep, concentration, and comfort, yet leaves no trace for conventional instruments to record. In many cases, local authorities and scientists can confirm that no obvious source exists, yet the perception persists. Entire communities have organized studies, mapping complaints and attempting to correlate them with infrastructure, weather, and geology, only to encounter patterns that resist explanation. Psychological and sociological investigations suggest that awareness of the hum can amplify its perceived intensity. Communities aware of the reports may become more sensitive to subtle noises, while individuals experiencing it in isolation often describe profound disorientation, frustration, and even fear. Still, the persistence of similar accounts across continents and cultures indicates that this is not merely a localized social phenomenon. It is something that transcends geography, time, and human expectation. The hum challenges the boundary between perception and reality, between measurable phenomena and personal experience. It exists at the intersection of physics, biology, and the human mind, suggesting that our understanding of sound, vibration, and environmental interaction remains incomplete. Could it be that the Earth itself hums in ways we cannot fully detect, producing vibrations too subtle or complex for conventional instruments? Or is it a product of the mind, revealing how our sensory systems interact with the environment in ways science has yet to decode? As researchers continue to explore the phenomenon, from rigorous acoustic measurements to neurological studies, the hum persists, silent to some, insistent to others. It is a subtle, pervasive reminder that our world contains layers of reality that can escape direct observation, whispering just beyond the threshold of perception. In the quiet hours, when the air is still and ordinary sounds fade, the hum endures, a low, enigmatic resonance threading through towns, forests, and fields. It asks us to listen more closely, to question the limits of our instruments, and to wonder what hidden vibrations ripple through the earth and the cosmos, unseen, yet unmistakably felt. What is the source of this haunting hum, and how many other subtle signals of our planet's mysteries remain undetected, waiting for us to notice them? On stormy nights, when the sky is torn by jagged streaks of lightning and the air vibrates with the electric tension of a brewing tempest, witnesses have occasionally reported a phenomenon that seems to defy the known rules of nature. A glowing sphere, sometimes as small as a baseball, sometimes large enough to fill a room, appears out of nowhere, hovering, drifting, or bouncing through the air. It emits light, heat, and sometimes a low hum, moving in ways that conventional physics struggles to explain. This is ball lightning, a fleeting, mysterious form of electricity that has captivated observers for centuries. Accounts of ball lightning span cultures and eras. In Europe during the 1600s, chroniclers described luminous spheres rolling across fields during thunderstorms. Sailors at sea reported glowing orbs darting over the water, occasionally entering ships and disappearing without a trace. In modern times, eyewitness reports continue, with objects sometimes passing through windows or lingering long enough for photographs and videos, though the phenomenon remains so rare and unpredictable that it is difficult to study under controlled conditions. Mainstream scientific explanations have attempted to reconcile ball lightning with known physics. Some suggest it is a plasma phenomenon, a self-contained ionized gas sphere stabilized by magnetic fields. Others propose that chemical reactions between vaporized silicon or metals in the atmosphere might produce glowing, long-lasting orbs. Laboratory experiments have succeeded in creating small, short-lived analogs under highly specific conditions, but reproducing a true, naturally occurring ball lightning event, the type described in first-hand accounts, has remained elusive. The challenges of understanding ball lightning are compounded by its extraordinary variability. Observers report a wide range of behaviors. Some balls move horizontally, others vertically. Some drift slowly, others dart with sudden velocity. Some vanish silently, while others explode with tremendous force. Its duration can vary from a fraction of a second to over a minute, defying simple classification. Even the colors observed, red, orange, white, blue, cannot be consistently explained by any single model. How can a physical process be so unpredictable yet consistently observable across continents and centuries? Speculative theories push the boundaries further. Some researchers have proposed that ball lightning might be a form of localized antimatter interaction, or even a manifestation of high-energy plasma connected to exotic atmospheric electromagnetic fields. Others have suggested that the orbs could involve self-contained microwave cavities, trapping energy in a way that allows the luminous sphere to persist longer than typical electrical discharges. While controversial and largely unverified, these ideas highlight the extent to which ball lightning continues to challenge conventional understanding. The phenomenon is not purely theoretical. It has had tangible consequences. Historical accounts describe fires, structural damage, and injuries caused by these glowing spheres, sometimes striking homes or aircraft. Yet just as often, ball lightning disappears without harm, leaving only the memory of its improbable passage. Its ephemeral nature, coupled with its occasional destructive potential, has imbued it with a sense of awe and unease, blurring the line between natural wonder and inexplicable hazard. Ball lightning also invites reflection on the limits of human perception. Many events occur during storms, a chaotic environment where lightning, thunder, wind, and rain can distort observations. Yet consistent reports from independent observers, often geographically and temporally distant, suggest that the phenomenon is not mere illusion or coincidence. Something real and physical is occurring, a process in the atmosphere that our instruments and models are only beginning to comprehend. Even today, researchers continue to seek evidence of ball lightning through high-speed cameras, radar detection, and controlled laboratory experiments. Each observation adds pieces to a puzzle that remains incomplete, hinting at a complex interplay between electrical energy, atmospheric chemistry, and perhaps unknown mechanisms in plasma physics. It is a reminder that nature can produce forms of energy and matter that exist only fleetingly, eluding sustained scrutiny yet leaving a lasting impression on those who witness them. Ball lightning challenges our assumptions about storms, electricity, and the behavior of matter under extreme conditions. It is a luminous enigma, appearing without warning, moving without clear cause, and disappearing without explanation. Its rarity and unpredictability render it one of the most captivating mysteries of atmospheric science. As storms continue to rage and lightning arcs across the sky, the potential for another glowing sphere to emerge remains. Hovering silently, glowing faintly, or darting unpredictably through the air, ball lightning persists as a reminder of the unknown forces that course through our world. What is the true nature of these ephemeral orbs, and what hidden rules of physics or atmospheric chemistry do they reveal? Even as science advances, the phenomenon endures, a fleeting whisper of mystery in the charged air, waiting for the next witness to glimpse its impossible, glowing form. Ball lightning challenges our assumptions about storms, electricity, and the behavior of matter under extreme conditions. It is a luminous enigma, appearing without warning, moving without clear cause, and disappearing without explanation. Its rarity and unpredictability render it one of the most captivating mysteries of atmospheric science. As storms continue to rage and lightning arcs across the sky, the potential for another glowing sphere to emerge remains. Hovering silently, glowing faintly, or darting unpredictably through the air, ball lightning persists as a reminder of the unknown forces that course through our world. What is the true nature of these ephemeral orbs? And what hidden rules of physics or atmospheric chemistry do they reveal? Even as science advances, the phenomenon endures, a fleeting whisper of mystery in the charged air, waiting for the next witness to glimpse its impossible, glowing form. Nestled in the high desert of northern New Mexico, the town of Taos stretches beneath wide cerulean skies, framed by the Sangre de Cristo Mountains. It is a place of striking natural beauty, where adobe buildings cast long shadows over dusty streets, and the air carries the scent of piñon and juniper. Yet for decades, a subtle, persistent mystery has lingered here, threading itself through the daily lives of residents, a sound that is felt more than heard, a vibration that is at once elusive and insistent. This is known as the Taos Hum. The phenomenon first drew widespread attention in the early 1990s, though anecdotal accounts suggest that a similar low-frequency noise may have been present for years prior. Residents describe it as a constant droning or rumbling, a bass-like resonance that permeates homes, streets, and even the landscape itself. For some, it is barely perceptible. For others, it is a source of sleepless nights, headaches, and a deep sense of unease. What makes the hum particularly confounding is its selectivity. Some people hear it clearly, while others in the same room hear nothing at all. Scientists have attempted to investigate the phenomenon with a variety of instruments, from audio recordings to seismic sensors. Yet, despite extensive studies conducted by both the U.S. government and independent researchers, no consistent environmental source has been identified. Unlike conventional noise pollution from traffic or industrial machinery, the Taos Hum seems to arise spontaneously, as if it exists at the edge of perception, detectable only by those sensitive to its particular frequency. Mainstream hypotheses suggest a combination of natural and human-made causes. Low-frequency sound waves, or infrasound, generated by distant machinery, wind over terrain, or atmospheric disturbances, could interact with the inner ear, producing the sensation of a continuous hum. Tectonic activity in the region, given Taos' proximity to fault lines and the Rio Grande Rift, has also been considered a potential contributor, creating subtle vibrations that resonate through the ground. Even the distant hum of power lines and industrial plants has been examined as a plausible factor. Yet none of these explanations fully accounts for the selective perception and variability reported by those affected. Speculative ideas extend the mystery further. Some researchers have pondered whether the hum could be a form of electromagnetic resonance, interacting with human biology in ways not fully understood. Others wonder whether it could be linked to more exotic phenomena, such as subtle shifts in the Earth's crust, previously unrecognized atmospheric effects, or even vibrations produced by the planet itself, imperceptible to conventional instruments. In every case, the evidence remains inconclusive, leaving the phenomenon suspended between observation and speculation. The human element of the Taos Hum adds another layer to its intrigue. Those who hear it often describe an almost tangible presence, a resonance that seems to occupy space as much as sound. For some, the hum is a source of profound discomfort, disrupting concentration, sleep, and daily routines. For others, it is merely a faint background hum, barely distinguishable from the everyday ambient sounds of the desert. The mystery is compounded by the fact that reports emerge and fade over time, as though the phenomenon itself ebbs and flows, responding to variables we cannot yet measure. Over the years, government agencies and scientific teams have attempted to document the hum, conducting surveys, audio recordings, and interviews with residents. Yet the results are inconclusive. Sensitive microphones often detect no unusual sound, while people continue to report the presence of a low-frequency vibration. The disconnect between measurement and perception raises profound questions about the nature of the phenomenon. Is it entirely physical, or does it straddle the boundary between physics and human perception? The Taos Hum challenges our understanding of sound, vibration, and the limits of human sensitivity. It exists at the intersection of geology, atmospheric science, and neurology, a reminder that the world contains layers of experience that cannot always be captured by instruments alone. It persists as a quiet, almost invisible presence, threading through homes and streets, a subtle reminder that there are mysteries that resist observation, even in a world filled with sensors and technology. As night falls over the high desert, when the wind dies and the mountains cast long shadows across the adobe buildings, the hum endures. It is a constant yet elusive companion, a sound that seems to originate from nowhere and everywhere at once. What is its true source? Why can some perceive it while others remain oblivious? And what other subtle, hidden phenomena ripple quietly through the world around us, waiting to be noticed? The Taos Hum remains an enigma, a reminder that even in seemingly tranquil places, the Earth can whisper secrets we are only beginning to hear. It challenges us to listen more closely, to question our assumptions about perception and reality, and to wonder what other subtle vibrations of mystery exist just beyond the reach of our understanding. In the heart of California's Death Valley, one of the hottest and driest places on Earth, stretches a flat, desolate expanse known as Racetrack Playa. Under the relentless sun, the cracked clay surface glistens white, a barren landscape that seems to resist life. Yet, scattered across this dry lakebed are stones, some weighing hundreds of pounds, each leaving behind a long, winding trail in the dust, a silent record of motion across the landscape. These are the sailing stones, an enigmatic phenomenon that has puzzled scientists, explorers, and photographers for nearly a century. The first recorded observations of the stones' trails date back to the early 20th century, when visitors noted that the rocks appeared to move on their own, shifting across the playa between visits. The trails are often straight or slightly curved, weaving across hundreds of meters, as if the stones had been guided by invisible hands. What makes the phenomenon particularly strange is that the rocks move without human or animal intervention, and in a region so dry and harsh with minimal wind, their motion seemed impossible. For decades, the mystery persisted, documented in photographs and journals, yet largely unexplained. Scientists have proposed various explanations over the years. Early hypotheses suggested strong winds, acting on wet clay, could push the rocks along. Others considered seismic activity or slippery ice sheets during rare winter rains as possible mechanisms. For decades, these theories could not fully account for the precision, distance, and consistency of the trails. The rocks' paths often change direction abruptly, and some stones move alone while others remain stationary, defying simple explanation. The mystery gained renewed attention with systematic studies beginning in the late 20th century. Researchers began monitoring the playa with time-lapse photography, motion-activated cameras, and sensors. In 2014, a breakthrough study revealed that under very specific conditions, thin sheets of ice forming on the playa during winter nights, combined with gentle winds, the rocks could indeed move, pushed slowly across the surface by floating ice panels. The discovery offered a plausible mechanism, yet the precise behavior of the stones, the timing, and the variety of trails still resist complete understanding. Some trails suggest sudden shifts or directional changes that appear inconsistent with slow ice movement. Speculative explanations have also emerged. Some propose that subtle electromagnetic forces in the playa's mineral-rich soil might influence the stones, or that microseismic activity could trigger movements at unexpected intervals. Others suggest that rare and complex interactions of wind, ice, and water might create conditions so fleeting and specific that they occur only under circumstances observed by few, explaining the stone's elusive and inconsistent motion. Even after decades of study, the sailing stones retain an aura of mystery, a reminder that nature sometimes operates in ways that challenge human intuition. What makes the sailing stones so compelling is the visual record they leave behind. Trails curve and meander across the flat clay, disappearing into the horizon. Each line is a silent testament to a movement invisible in real time, a motion that occurred slowly or suddenly, without witnesses, leaving only the scars of passage. Some stones rest in clusters, while others travel alone. And in each case, the patterns suggest a story that is partially told, but never fully revealed. The phenomenon also invites reflection on patience, observation, and the hidden rhythms of the natural world. It reminds us that even in the harshest, seemingly inert landscapes, forces, mechanical, meteorological, or perhaps yet unknown, operate with subtlety and complexity. What other quiet, imperceptible processes occur around us, unnoticed, leaving trails in the sand, the soil, or the air? As the sun sets over racetrack playa, casting long shadows across the cracked surface, the rocks rest silently, each one a potential traveler waiting for the right conditions to begin its journey anew. The trails etched behind them speak of motion and mystery, of natural laws at work in ways we only partially comprehend. The sailing stones of Death Valley endure as both a scientific puzzle and a poetic symbol. They are evidence that the Earth itself can move in unexpected ways, tracing paths invisible to most of us, guided by forces subtle, precise, and mysterious. What truly dictates their motion? How many factors, seen and unseen, come together to allow such improbable journeys? The stones offer no answers, only the quiet, winding paths of wonder, inviting us to witness, question, and imagine the hidden dynamics of our planet. Beneath the familiar landscapes of continents, oceans, and mountains lies a realm we can never visit directly, a world of crushing pressure, molten rock, and searing heat. Earth's core, hidden nearly 3,000 kilometers beneath our feet, is a place of extremes, where iron and nickel are compressed into a dense, almost alien state, and temperatures rival the surface of the sun. It is a region of the planet that hums with energy, shaping magnetic fields, driving volcanic eruptions, and influencing the very movement of tectonic plates. Yet, even as we study it, the core presents anomalies that continue to baffle scientists, suggesting that the heart of our world holds secrets we have only begun to glimpse. Seismology, the study of how waves generated by earthquakes travel through Earth, has provided our clearest window into this hidden world. P waves and S waves ripple through the mantle and inner layers, revealing boundaries, densities, and compositions. Yet, as precise as these measurements are, they have exposed strange irregularities. In the 1990s, researchers observed that the inner core does not rotate uniformly. Some sections appear to spin slightly faster than the planet's surface, while others lag behind, a phenomenon known as differential rotation. What could cause the solid iron at the center of Earth to behave in such a seemingly independent manner? Even stranger, the inner core itself may not be uniform. Some studies suggest a layered structure with an inner core, exhibiting a different crystalline alignment than the surrounding iron. Variations in seismic wave speeds indicate regions that defy the expectations of homogeneity. Could these patterns reflect ancient processes frozen in time, remnants of the planet's formation billions of years ago? Or are they the result of ongoing, dynamic changes deep beneath the surface, invisible yet fundamental to Earth's magnetic heartbeat? The outer core, a molten ocean of iron and nickel surrounding the solid inner core, presents its own enigmas. Convection currents within this layer generate Earth's magnetic field, a protective shield that extends far into space. Yet the field itself behaves unpredictably. Magnetic poles drift, sometimes more rapidly than models predict, and at intervals the field has reversed entirely, with north and south swapping places. Could fluctuations in the outer core's flow, the twists of its molten currents, hold answers not just to the drift of the poles but to sudden anomalies observed in the geomagnetic record? And how do these flows interact with the inner core, a dense, slowly spinning sphere, to produce the complex patterns we detect on the surface? Alternative theories venture into even more speculative territory. Some scientists have suggested that pockets of unexpected composition, lighter or heavier elements trapped deep within the core, might influence its rotation and magnetic behavior. Others have proposed that the inner core might not be perfectly spherical, but slightly asymmetric, introducing subtle distortions in the way seismic waves travel. A few fringe ideas even entertain the notion of remnants of cosmic collisions or ancient planetary mergers embedded in Earth's deepest layers, frozen in time yet affecting the behavior of the planet today. While unproven, these hypotheses illustrate the extent to which the core remains a frontier of mystery. The implications of understanding these anomalies extend far beyond academic curiosity. Earth's core is the engine of our planet, dictating everything from volcanic activity to the geomagnetic protection that shields life from solar and cosmic radiation. If the core behaves differently than we expect, if sections rotate or oscillate independently, what does that mean for our models of tectonic movement, magnetic reversals, and the thermal evolution of the planet? Could there be phenomena occurring deep within, imperceptible to current instruments, yet shaping life on the surface in subtle but profound ways? Despite advances in seismology, high-performance simulations, and satellite measurements of magnetic fields, the core remains largely inaccessible, its secrets encoded in the ripples and distortions that propagate through Earth's layers. Each earthquake, each measurement, provides a fleeting glimpse, yet a complete understanding eludes us. It is a reminder that even beneath our feet, in the solid, seemingly unyielding center of our world, nature holds mysteries that resist easy explanation. As we probe ever deeper, through models, simulations, and indirect measurements, Earth's core continues to challenge our assumptions about planetary interiors. It is a realm of extremes, of heat and pressure, motion and magnetic influence, and yet it is also a realm of uncertainty. What drives the differential rotation of the inner core? What hidden structures lie within the molten outer layer? And what other anomalies, subtle and profound, remain undetected, quietly shaping the surface world above? In the stillness beneath continents and oceans, the core endures, a deep, rotating enigma at the heart of our planet. It is a place we cannot touch, a domain we can only infer through careful observation and imagination. And it is here, in this hidden, extreme environment, that Earth quietly reminds us there are mysteries that dwell at the very center of our world, waiting to be understood, or perhaps simply marveled at. Beneath the vast, frozen expanse of Antarctica lies a hidden world, one that has remained untouched for millions of years. Thick sheets of ice, kilometers deep, conceal dark, silent bodies of water sealed off from sunlight and the surface environment. These are the subglacial lakes of Antarctica, a network of liquid water reservoirs trapped beneath the ice, mysterious and isolated, quietly flowing beneath a continent that seems entirely frozen. Among them, Lake Vostok stands as the most famous, a body of water larger than Lake Ontario, hidden under more than 4 kilometers of ice, its surface untouched for possibly tens of millions of years. The discovery of these lakes began in the mid-20th century when radar surveys revealed unusual flat, reflective areas beneath the ice. Subsequent investigations confirmed the presence of liquid water, kept from freezing by a combination of immense pressure, geothermal heat, and perhaps salts or other dissolved compounds. The realization that liquid water could exist beneath such thick ice challenged assumptions about the limits of life and the resilience of ecosystems in extreme environments. The intrigue of Antarctica's subglacial lakes is heightened by the possibility of life within them. Despite complete isolation from sunlight and atmospheric oxygen, some lakes may harbor microbial ecosystems surviving in extreme cold under immense pressure and sustained only by chemical energy from the surrounding rock. Scientists drilling through the ice have collected water samples from lakes such as Whillans and Mercer, revealing microorganisms unlike any found elsewhere on Earth. How life survives in these conditions remains a profound question, and each discovery hints at the possibility that life can adapt to environments far beyond what was previously imagined. Could these lakes offer a window into how life might exist beneath the icy crusts of moons such as Europa or Enceladus, far from the warmth of a sun? The geology beneath the ice adds another layer of mystery. Subglacial lakes are interconnected through networks of channels and rivers, some of which appear to flow intermittently, driven by shifts in ice pressure or subtle geothermal gradients. The lakes themselves may rise and fall over time, their surfaces moving in response to ice sheet dynamics, yet precise mapping is extremely challenging. Radar and satellite measurements provide glimpses, but the hidden waterways remain largely inaccessible, a labyrinth of liquid rock and water beneath miles of ice. Alternative and more speculative theories have emerged alongside scientific inquiry. Some researchers have suggested that unique chemical compositions, perhaps enriched in rare minerals or gases, could influence the lake's stability, temperature, or even the evolution of life within them. Others have proposed that these hidden waters could hold records of ancient climates, preserving DNA or other biological traces from epochs long past, a frozen archive of Earth's distant history. The notion that each lake may contain unique conditions, differing subtly in chemistry, pressure, or isolation, adds a sense of unpredictability to these hidden realms. The study of these lakes is not without its challenges and controversies. Drilling into subglacial waters requires extreme care to prevent contamination, as even the smallest introduction of surface microbes could destroy the pristine environment and compromise research. Yet scientists press forward, aware that each sample, each measurement, offers a glimpse into a world almost entirely cut off from our own. The subglacial lakes are more than just bodies of water. They are laboratories of extreme biology, geology, and climate history, inaccessible yet tantalizingly close in concept. Antarctica's subglacial lakes serve as a reminder of how much of our planet remains unexplored, even under our feet. They challenge our notions of habitability, resilience, and the adaptability of life. They reveal that Earth contains hidden realms, silent and isolated, moving to rhythms that we are only beginning to measure, in landscapes that seem eternal and immutable. As explorers and scientists continue to probe the ice, the lakes remain enigmatic, their waters dark and untouched, reflecting the silence of a continent frozen in time. What other secrets lie beneath the kilometers of ice? Could the lakes contain unknown life forms, undiscovered minerals, or evidence of Earth's climatic past preserved for millennia? And what might these frozen hidden waters tell us about the possibilities of life in the most extreme environments across the cosmos? Beneath the Antarctic ice, in a world of darkness and immense pressure, the subglacial lakes endure, silent, cold, and profound. They are a reminder that even in an age of satellites, high-speed travel, and advanced technology, parts of our planet remain mysterious and largely untouched, holding secrets that invite exploration, contemplation, and wonder. Across the world, from the quiet suburbs of the American Midwest to remote coastlines and open plains, people have reported an unsettling phenomenon: sudden, powerful explosions that seem to come from nowhere. Known simply as the mystery booms, these low-frequency, thunderous sounds rattle windows, shake the ground, and reverberate through the air, yet often leave no visible source. Unlike conventional thunder or artillery, these booms appear without warning, striking fear, confusion, and curiosity in equal measure. Their origin has long eluded scientists, creating one of the most perplexing and persistent auditory mysteries of our modern age. Reports of unexplained booms are not a new occurrence. Historical accounts describe similar events centuries ago, often dismissed as folklore, atmospheric disturbances, or distant cannon fire. Yet in the 20th and 21st centuries, as populations expanded and technology advanced, the phenomenon became impossible to ignore. Entire towns have reported sudden rumbles, only to find no seismic activity, no evidence of explosions, and no meteorological explanation. Residents describe the booms as deeply resonant, sometimes shaking homes, rattling doors, or even triggering vibrations in vehicles, leaving behind only a lingering sense of unease. Scientists investigating these events have proposed a variety of explanations. Some suggest that they may be linked to seismic activity, small-scale earthquakes so minor that they escape detection by standard monitoring equipment. Others point to atmospheric phenomena, sonic booms from high-altitude aircraft, supersonic jets, or meteor entries that produce shock waves capable of traveling long distances. Even industrial activity, from mining operations to large-scale construction, has been examined as a possible source. Yet, in many cases, none of these explanations fits the timing, location, or characteristics of the sounds, leaving experts grasping for answers. The booms are especially confounding because of their apparent randomness and global distribution. They have been reported in coastal regions of England, rural towns in the United States, isolated communities in Canada, and even remote areas of Australia and New Zealand. Some regions experience repeated occurrences over months or years, while others hear them only sporadically. Why do some areas seem more prone to these noises than others? Is it a matter of geological conditions, atmospheric quirks, or something entirely unknown? Speculative theories venture further into the unknown. Some suggest that the booms could be the result of subterranean gas pockets suddenly collapsing or releasing pressure, a form of underground thunder beneath the Earth's surface. Others consider the possibility of unusual electromagnetic interactions with the ionosphere, triggering audible phenomena that resonate in unexpected ways. A few fringe hypotheses even entertain the notion of secret military tests, clandestine experiments, or rare cosmic events interacting with Earth's atmosphere in subtle, explosive ways. While these ideas remain unverified, they illustrate the profound challenge the mystery booms present to conventional science. What causes such loud, localized events without leaving clear evidence? The human perception of the booms adds another layer of complexity. Because the sounds are low frequency, often at the threshold of human hearing, they are sometimes accompanied by vibrations that are felt as much as heard. Some observers report headaches, disorientation, or a sense of pressure in the ears, further complicating efforts to measure and analyze the phenomenon. These subjective experiences make it difficult to separate perception from physical reality, yet the consistency of reports across decades and continents indicates that there is indeed a real, physical cause, even if it remains hidden. Investigations continue using sensitive microphones, seismic arrays, and high-speed cameras, yet the mystery booms remain frustratingly elusive. Scientists have documented several events in real time, capturing audio signatures and vibrations, but each case adds questions rather than answers. The data hint at a complex interplay of geological, atmospheric, and perhaps even human-induced factors, yet a definitive explanation remains just out of reach. The mystery booms remind us of the limits of our knowledge and the hidden forces at work in the world around us. They challenge assumptions about sound, vibration, and the ways energy travels through the Earth and atmosphere. Even in a world saturated with monitoring equipment and scientific instruments, some events occur beyond our ability to predict or fully understand. As night falls over towns and rural landscapes where these booms have echoed, the phenomenon endures, a deep, rolling sound that rises without warning, reverberates through homes, and vanishes as mysteriously as it arrived. What unseen forces trigger these sudden, thunderous events? Could they be linked to the movements of the Earth itself, the atmosphere above, or phenomena we have yet to observe? And what other subtle, powerful sounds wait quietly in the world, unheard and unexplained, until they emerge to remind us of the mysteries still lurking at the edge of perception? The mystery booms continue to resonate as a reminder, even in our most carefully measured environments. The Earth and the forces that shape it retains secrets that are both audible and invisible, waiting for those willing to listen, investigate, and wonder. Beneath the rolling waves of the world's oceans, in shadowed coral reefs, dark kelp forests, and the silent depths of the abyss, one of nature's most enigmatic creatures moves with grace and intelligence: the octopus. Known for its supple body, dexterous arms, and uncanny ability to vanish into its surroundings, this cephalopod has fascinated humans for centuries. Yet beyond its visible marvels, the octopus harbors an even deeper mystery, one written in the language of life itself: its DNA. Unlike any other animal, the octopus possesses a genetic code that is both extraordinary and perplexing, challenging our understanding of evolution and the very nature of complex life. The genome of the common octopus, Octopus vulgaris, contains approximately 33,000 protein-coding genes, more than humans, more than most mammals, and yet organized in a way that defies conventional patterns. Scientists sequencing the octopus genome discovered a proliferation of certain gene families, particularly those related to neural development and signaling. These expansions suggest that the octopus has evolved remarkable intelligence independently of vertebrates, developing a sophisticated nervous system capable of learning, problem-solving, and even exhibiting behaviors we once thought uniquely human. But the genetic story grows stranger. Many of these genes appear scattered, reordered, and shuffled in ways rarely seen in other species, creating a genomic architecture that resembles a mosaic more than a linear sequence. Equally fascinating is the octopus's ability to rewrite certain genes during its lifetime, a process known as RNA editing. While most animals have relatively stable genetic instructions, octopuses can alter the expression of thousands of their genes, particularly those associated with neural function. This molecular flexibility allows them to adapt rapidly to environmental challenges, fine-tuning their biology without changing their inherited DNA. Could this extraordinary adaptability be the key to their problem-solving skills, their camouflage mastery, or their remarkable memory? And how did evolution sculpt a genome so uniquely dynamic, so fundamentally different from the genetic blueprints of vertebrates? The origins of these genomic anomalies continue to puzzle scientists. Comparisons with other mollusks and invertebrates suggest that the octopus diverged from its relatives hundreds of millions of years ago, yet its neural sophistication and DNA complexity seem almost unprecedented in the animal kingdom. Researchers have speculated about bursts of evolutionary innovation, perhaps driven by environmental pressures, predation, or competition in the ocean's complex ecosystems. Others point to the role of transposable elements, so-called jumping genes, which have proliferated in the octopus genome, potentially reshaping gene regulation in ways that accelerate evolutionary novelty. But why these processes produced such a sophisticated intelligence in cephalopods alone remains an open question. Beyond genetics, the octopus presents biological features that amplify the mystery. Its brain is decentralized. Roughly 2/3 of its neurons reside in its arms, allowing each limb to process information independently. Coupled with a highly plastic genome, this decentralized intelligence suggests a form of cognition fundamentally different from vertebrates, challenging assumptions about what it means to be intelligent. Could the unique structure of the octopus's DNA have facilitated the evolution of such a system, enabling its neural network to function in ways that seem alien to us? Speculative theories extend even further. Some researchers ponder whether the octopus's genetic and neurological quirks hint at mechanisms of evolution that remain largely unexplored in other species, a parallel path of innovation in deep time. Others wonder whether its adaptability and intelligence could inform our understanding of consciousness itself, suggesting that life can develop complex cognition in forms radically different from our own. In every case, The octopus's DNA anomaly is more than a curiosity. It is a window into life's capacity for diversity, resilience, and surprise. The mystery is deepened by the practical challenges of studying these creatures. Octopuses live brief lives, often less than 5 years, making long-term observations difficult. They are solitary, highly adaptable, and capable of remarkable camouflage and escape, complicating both behavioral and genetic studies. Yet each investigation reveals more layers: genes that defy prediction, behaviors that challenge expectations, and a biology that seems to operate according to principles both familiar and entirely new. As sunlight filters through the surface of the ocean and fades into the inky blackness of the deep, the octopus moves silently through its realm, a creature of intelligence, adaptability, and enigma. Its DNA, vast and unusual, hints at evolutionary pathways that are still poorly understood, raising questions about the limits of biological complexity and the nature of life itself. What other secrets lie within the octopus's genome, hidden in sequences that seem almost alien? Could studying these mysteries illuminate not only cephalopods, but the broader principles of intelligence, adaptation, and evolution across life on Earth? And what does it mean that a creature so unlike ourselves can think, learn, and adapt in ways that challenge our deepest assumptions about the biological world? In the depths of the ocean, among shadows and currents, the octopus endures, its very DNA a living puzzle, an invitation to explore the boundaries of life, intelligence, and the unexplained. Beneath the tranquil surface of temperate oceans, where sunlight filters through the water in dappled patterns and gentle currents sway, drifts a creature unlike any other in the animal kingdom. Tiny, translucent, almost ethereal, the Turritopsis dohrnii, commonly known as the Immortal Jellyfish, moves with a fluid grace, its delicate bells pulsating in silence. To the casual observer, it might seem fragile, ephemeral, a fleeting fragment of the marine world. Yet this small jellyfish harbors a secret that challenges our understanding of life itself: the capacity, under the right conditions, to seemingly reverse its own aging process, a phenomenon that has left scientists both awestruck and perplexed. The story of the immortal jellyfish began to attract attention in the late 20th century, when marine biologists observed an unusual behavior in laboratory conditions. When faced with stress, injury, or environmental threats, this jellyfish can transform its mature cells back into a younger, polyp-like state. In effect, it can return to a previous stage of its life cycle, creating a loop that, in theory, could repeat indefinitely. Unlike other species that simply reproduce and die, the immortal jellyfish possesses a biological mechanism that appears to defy the natural limits of aging. How could a multicellular organism achieve such a feat, seemingly rewriting the fundamental rules of life? The mechanism behind this phenomenon, known as transdifferentiation, is itself extraordinary. Cells that have already specialized, muscle, nerve, or digestive cells, can revert to an earlier, more flexible state and then develop into new cell types. This process allows the jellyfish to regenerate damaged tissues, effectively rejuvenating itself in ways that no vertebrate is known to match. For decades, researchers have studied the genetic and biochemical pathways that enable this transformation, uncovering complex signaling systems that control cell fate. Yet despite these discoveries, the deeper evolutionary and ecological purpose of this capability remains enigmatic. Why would nature evolve such a cycle? And how common might similar mechanisms be in other, less studied organisms? The implications of the immortal jellyfish extend beyond the scientific laboratory. Its existence challenges assumptions about mortality, aging, and the boundaries of biological potential. If a tiny marine creature can circumvent the natural progression from youth to old age, could other species, perhaps even our own distant relatives, possess hidden pathways to longevity that remain undiscovered? Some scientists speculate that understanding the jellyfish's cellular plasticity might offer insights into regenerative medicine, aging, and the treatment of degenerative diseases. Others caution that the jellyfish's immortality is not absolute. In the wild, predators, disease, and environmental hazards limit its lifespan, meaning that the remarkable cycle is observed primarily under controlled conditions. Yet the mere possibility of biological reversal captivates the imagination. Beyond the laboratory, the immortal jellyfish raises philosophical questions. Life, as we understand it, is a linear progression: birth, growth, reproduction, and death. Yet here is an organism that seems to step outside that sequence, entering a biological loop that appears to have no natural endpoint. Could this represent an overlooked evolutionary strategy, a way for species to survive in volatile or extreme environments? Or is it an isolated quirk, a rare exception in the grand tapestry of life on Earth? Even in the depths of scientific inquiry, these questions remain largely unanswered. The creature's subtle beauty mirrors the mystery it embodies. Its almost invisible form drifts silently through the water, bell pulsing rhythmically, arms extended in delicate arcs. To witness it is to confront the strange possibility that life is far more malleable and resilient than previously imagined. Its cellular flexibility, its capacity for renewal, challenges the finality of death and reminds us of nature's enduring capacity for innovation and surprise. As ocean currents carry it through shadowed depths, the immortal jellyfish continues its quiet, enigmatic existence. It is a living paradox, fragile yet enduring, simple yet profoundly complex, a reminder that even in the most studied corners of biology, surprises abound. What other creatures, still unknown, might possess similar abilities, hidden in the ocean's depths? And what secrets about the nature of aging, life, and survival does this tiny jellyfish hold, waiting to be unraveled by those willing to look deeper? In the endless blue of the sea, where light fades and mysteries accumulate in the silence, the immortal jellyfish drifts on, a living testament to the limits of human understanding, and a quiet invitation to wonder at the secrets life still guards beneath the waves. Across the tapestry of human history, from the earliest cave paintings to the bustling streets of modern cities, one subtle distinction has quietly marked a fraction of humanity: left-handedness. Those who favor their left hand, estimated to comprise roughly 10% of the population, navigate a world designed overwhelmingly for their right-handed counterparts. From scissors to musical instruments, from desks to kitchen knives, the world seems tailored to one orientation, leaving left-handers to adapt, innovate, and at times struggle. Yet what drives this asymmetry of human biology remains a profound and largely unsolved mystery. The study of handedness stretches back centuries. Ancient texts and archaeological records reveal left-handed individuals in a variety of societies, sometimes revered for their uniqueness, sometimes viewed with suspicion. In medieval Europe, left-handedness was often stigmatized, associated with bad omens or unnatural traits, while in other cultures it was embraced or simply accepted as a natural variation. Skeletal remains and ancient tools suggest that even tens of thousands of years ago, left-handed individuals existed in roughly the same proportions as today. What determined this division in the human population so early in our history? Modern science has attempted to untangle the enigma through genetics, neurobiology, and anthropology. Studies indicate that handedness is influenced by a complex interplay of genes, but no single left-hand gene has been identified. Instead, researchers have proposed networks of genetic factors that subtly bias brain development, affecting the dominance of one hemisphere over the other. Neurologically, handedness is linked to the asymmetry of the brain. The left hemisphere typically controls language and fine motor skills, While the right hemisphere typically controls spatial skills and visual perception, right governs spatial and holistic processing. Yet why this asymmetry manifests in roughly 90% of humans favoring the right hand, while the remaining 10% favor the left, remains uncertain. Beyond genetics and anatomy, environmental influences add another layer of intrigue. Some theories suggest prenatal factors, such as hormonal exposure in the womb, might influence which hand an individual prefers. Others point to cultural reinforcement, noting that societal pressures have historically pushed children to favor their right hands, potentially masking underlying biological tendencies. Yet even with these insights, handedness resists simple explanation, straddling biology, environment, and culture in a way that continues to puzzle scientists. Left-handedness also presents a paradox in evolutionary terms. On one hand, left-handers often face challenges in a right-dominated world. Tools, weaponry, and social norms frequently disadvantage them. On the other, research suggests left-handers may benefit in certain contexts. In sports, combat, or competitive games, the unpredictability of left-handed opponents can provide a distinct advantage, hinting at a selective benefit that may have helped maintain this trait across generations. Could it be that nature preserves left-handedness as a small, adaptive minority, balancing the majority with rare advantages that emerge only under specific circumstances? Cultural and neurological anomalies further complicate the picture. Left-handedness correlates in some studies with certain cognitive and neurological traits, both advantageous and disadvantageous. Creativity, divergent thinking, and unique problem-solving skills have been linked to left-handedness, though the findings are inconsistent. Some neurological conditions show slightly higher prevalence among left-handed populations, suggesting a deeper, more intricate relationship between brain development, lateralization, and individual variability. How much of this is coincidence, and how much points to hidden patterns in human evolution still invisible to our understanding? The mystery of left-handedness is mirrored in the broader phenomenon of asymmetry in nature. From the coiling of snail shells to the directional spirals of galaxies, from the placement of organs within the human body to the lateralized hunting strategies of animals, the universe itself seems to favor certain directions, yet allows exceptions. Why does this occur? Is left-handedness simply one of many expressions of nature's subtle preferences and anomalies, a small yet telling clue in a much larger puzzle of asymmetry and function? Even in the modern age, left-handedness retains its aura of quiet mystery. Every left-handed person navigating a right-handed world becomes a living testament to an evolutionary quirk, a reminder of the diversity of human biology. Their struggles, adaptations, and innovations echo a deeper story about how subtle differences shape perception, cognition, and interaction with the environment. In a world dominated by the right hand, the left-handed minority continues to move through life in quiet defiance. Their very existence a reminder that even in traits as familiar as which hand we favor, nature holds secrets that remain, for now, tantalizingly unsolved. Across the quiet plains, dense forests, and winding rivers of our planet, nature often moves with a rhythm that is both predictable and astonishing. Seasons change, temperatures shift, and with them, countless species embark on journeys that have been etched into their behaviors for millennia. Birds take flight toward distant breeding grounds, whales traverse thousands of miles through icy oceans, and caribou trek across tundras in search of fresh grazing. Yet, within this natural order, scientists have observed a phenomenon that defies expectation: sudden, large-scale animal migrations that appear without clear cause, leaving researchers scrambling to understand the forces behind these extraordinary movements. Sudden animal migrations have been documented in multiple species and regions, often occurring outside typical migratory patterns. In Africa, vast herds of zebras and wildebeest have been observed altering their routes abruptly, moving hundreds of miles across unfamiliar terrain. In North America, flocks of birds have changed their flight paths dramatically, sometimes appearing in locations far removed from historical patterns. These movements can involve thousands, even millions of individuals, creating a spectacle that is both mesmerizing and puzzling. What triggers such coordinated, large-scale shifts? How do animals sense when to move, especially when the signals are subtle, sudden, or seemingly invisible to human observation? Researchers have proposed a variety of explanations for these enigmatic migrations. Environmental changes, including droughts, floods, wildfires, and shifts in vegetation, are often implicated. Animals may respond to altered food availability, water scarcity, or changes in temperature, moving rapidly to survive. Yet many observed migrations occur without any obvious environmental stressor, raising questions about the hidden cues that guide such behavior. Could there be forces or signals that humans cannot perceive, magnetic anomalies, atmospheric vibrations, or even subtle chemical changes that influence the timing and direction of these journeys? Historical records suggest that sudden migrations are not a recent phenomenon. Accounts from explorers and naturalists in the 18th and 19th centuries describe instances of animals appearing en masse in unexpected regions, sometimes devastating crops or altering ecosystems. Indigenous oral traditions often include stories of mysterious movements of herds, flocks, or schools of fish, suggesting that humans have long been witness to these perplexing natural events. Yet, despite centuries of observation, the underlying mechanisms remain elusive, and the phenomenon continues to challenge conventional ecological understanding. The coordination required for sudden migrations is itself a subject of fascination. How do animals communicate and align their movements so precisely, often over vast distances? In some species, social structures, pheromones, or vocal signals may play a role. In others, innate instincts and environmental sensing seem to guide their path with uncanny accuracy. Scientists have speculated that some species may possess sensory abilities beyond human perception, detecting shifts in the Earth's magnetic field, infrasound from distant storms, or even subtle changes in atmospheric pressure. Such capabilities, if confirmed, would point to a world of animal perception that operates alongside, yet largely invisible to, human experience. Speculative theories extend further, considering the possibility of unknown planetary or cosmic influences. Could gravitational shifts, solar activity, or geomagnetic fluctuations subtly trigger mass movements? While these ideas remain on the fringe, they reflect the depth of mystery that sudden animal migrations inspire. For all the knowledge accumulated through satellite tracking, tagging, and ecological studies, there remains a profound sense of wonder. These creatures often act with an awareness, timing, and coordination that we can observe but not fully explain. The consequences of sudden migrations are significant, not only for the species involved but for the ecosystems they traverse. Entire food webs can be disrupted, habitats temporarily abandoned, and human communities affected by unexpected encounters. Yet these events also offer insight into the resilience and adaptability of life, illustrating how organisms can respond in real time to changing conditions, sometimes in ways that appear almost prescient. As dusk falls over rivers, plains, and forests, the sight of thousands of animals moving as one, an undulating river of life, remains a powerful reminder of the mysteries hidden in nature's patterns. Each migration is a story written in instinct, environment, and perhaps forces we do not yet fully comprehend. What invisible signals guide these creatures? How much of their behavior is predetermined, and how much emerges spontaneously in response to subtle changes in the world around them? And what other secrets of perception, communication, and environmental awareness lie hidden in the animal kingdom, waiting for us to notice. In the shifting shadows of the wild, sudden migrations continue to unfold, silent yet dramatic, ordinary yet inexplicable, a living testament to the enduring mysteries that surround life on Earth and the questions that remain unanswered despite our ever-expanding scientific gaze. Along remote stretches of coastline, in the silent depths of rivers, and across open plains, scenes occasionally emerge that defy explanation and evoke both sorrow and bewilderment. Mass animal deaths. Birds fall from the sky in bewildering numbers. Fish wash up on shores by the thousands, and herds of mammals are discovered lifeless in forests or fields, seemingly without warning. These events, often sudden and widespread, leave communities and scientists alike searching for answers, grappling with the scale of loss and the unsettling mystery of what could drive so many creatures to perish at once. Reports of mass animal deaths stretch back through history. Ancient chronicles recount flocks of birds collapsing over fields, fish drifting in rivers, and strange epidemics afflicting wildlife. Indigenous accounts often speak of unusual occurrences in nature, where the sudden death of animals heralded omens or marked shifts in the environment. While human observation has always noted these events, modern records, enhanced by satellites, drones, and global communication, reveal that such phenomena occur across continents, affecting species ranging from seabirds and bats to fish, marine mammals, and terrestrial herds. What mechanisms can cause such dramatic, simultaneous loss? Are these events entirely natural, or do unseen forces occasionally intervene in ways we have yet to understand? Scientific explanations often point to environmental and biological causes. Disease outbreaks, toxic algal blooms, sudden temperature fluctuations, or chemical contamination can decimate populations rapidly. Starvation or drought, compounded by human activity, may leave herds or flocks vulnerable. Even meteorological phenomena, such as storms or lightning strikes, can result in sudden fatalities among densely grouped animals. Yet in many recorded instances, no clear cause has been identified. Birds have fallen from clear skies, fish have died in seemingly uncontaminated waters, and mammals have perished in patterns that defy standard epidemiology. How is it possible that such catastrophic events can unfold without leaving a traceable signature? The coordination of these deaths can be particularly puzzling. Sometimes the scale of an incident suggests a trigger that is synchronous or environmental on a massive scale. In other cases, the randomness of locations, timing, and affected species complicates analysis, creating patterns that seem almost chaotic. Could there be subtle, undetected environmental shifts, changes in magnetic fields, atmospheric conditions, or seismic activity that animals perceive but humans do not? Might some species have sensitivities to vibrations, chemicals, or electromagnetic fluctuations that render them vulnerable to unseen hazards? Historical examples illustrate the range and mystery of these events. In 2011, tens of thousands of migratory birds were found dead across Arkansas, Louisiana, and Mississippi in a single night. In 2005, millions of sardines washed ashore along the California coast without a clear cause. In Russia's Siberian tundra, entire reindeer herds have been found dead under circumstances that defy conventional understanding. Even in more recent years, similar events continue to occur worldwide, often attracting global attention, yet leaving investigators with more questions than answers. Why do these events recur, often in different species and ecosystems, with causes that remain elusive? Some researchers propose that rare or complex interactions between multiple factors could explain mass deaths. Disease, environmental toxins, sudden weather changes, and human interference might combine in ways that are difficult to detect or reproduce experimentally. Yet even with sophisticated modeling, the unpredictability and timing of many events remain confounding. In some instances, the scale of the mortality suggests a force acting beyond localized conditions, a puzzle that invites speculation but resists definitive explanation. Beyond the scientific curiosity lies a deeper reflection on the fragility and interconnectedness of life. Mass animal deaths remind us that ecosystems operate on delicate balances and that forces beyond human perception can impact them in profound ways. Each incident carries both ecological and symbolic weight, revealing vulnerabilities in species, environments, and perhaps even our understanding of the natural world itself. As we confront these tragic and mysterious events, questions linger. What unseen patterns or forces could be guiding these occurrences? How do species respond, adapt, or succumb to sudden mortality en masse? And what secrets about environmental sensitivity, animal perception, and the limits of our observational tools remain hidden, waiting for those willing to investigate further? In rivers, forests, and skies around the world, the dead tell a story that science has yet to fully decipher, a quiet, haunting reminder that the natural world retains mysteries both vast and immediate, and that, despite our advances, life itself can still unfold in ways that defy understanding. In the quiet of a dimly lit room, a single human figure sits in stillness, eyes closed, chest rising and falling with measured breaths. Within this ordinary body lies something extraordinary: consciousness. The subtle awareness of thought, emotion, and perception, the inner experience of self, and the capacity to observe, reflect, and imagine. These are the hallmarks of human consciousness, a phenomenon that has captivated philosophers, scientists, and mystics for millennia. Yet despite centuries of study and speculation, the nature of consciousness remains one of the most profound mysteries of existence, resisting full explanation even in an age of advanced neuroscience. The story of human consciousness is entwined with the evolution of the brain itself. Fossil records suggest that hominins developing complex neural structures as far back as 200,000 years ago may have possessed rudimentary forms of self-awareness. Ancient civilizations pondered the nature of thought and soul, from the writings of Egyptian scholars in 3000 BC to Greek philosophers such as Plato and Aristotle, who debated whether consciousness emerged from the body, the soul, or some combination of both. Across cultures, myths, rituals, and contemplative practices indicate a persistent fascination with the inner world, an acknowledgement that human experience contains layers that seem to transcend observable physical processes. Modern neuroscience has illuminated aspects of consciousness, revealing how networks of neurons in the cerebral cortex and other regions generate perception, memory, and decision-making. Brain imaging allows scientists to trace the neural correlates of specific thoughts, emotions, and sensory experiences. Yet, even with these advances, a central question remains. How does the firing of neurons give rise to the vivid, subjective experience of being? How do electrical impulses, chemical signals, and synaptic connections coalesce into the rich tapestry of awareness that allows a human to experience love, fear, joy, or wonder? The hard problem of consciousness, the gap between physical processes and subjective experience, remains largely unsolved. Some researchers explore consciousness through evolutionary perspectives. It may have conferred survival advantages, allowing early humans to anticipate threats, communicate, and navigate complex social structures. Yet this practical explanation does not address the deeper enigma of why awareness feels like anything at all. Could consciousness be more than a byproduct of neural activity, a phenomenon that emerges from the interaction of matter but retains properties that defy reductionist explanation? Philosophical and speculative theories push the boundaries even further. Some suggest that consciousness may be a fundamental feature of the universe, akin to space, time, or energy, Could awareness exist, in some form, beyond the brain, embedded in the very fabric of reality? Others explore altered states, dreams, meditation, near-death experiences, and psychedelic encounters, where perception and cognition operate in ways that seem to bypass ordinary neural mechanisms. These states hint at layers of consciousness that remain hidden under the surface of waking life, suggesting that what we experience moment to moment may be only a fraction of a more expansive inner reality. Across cultures and time, humans have wrestled with the paradox of consciousness. It is at once intimately familiar and utterly elusive. Language, art, and science attempt to capture it, yet the essence slips away with each description. Even within the brain, localized damage can erase memory, impair perception, or alter personality, yet the continuity of self often persists, pointing to a complexity that challenges linear understanding. Could consciousness be a dynamic, distributed phenomenon rather than a singular center of experience? Could it extend beyond individual brains, connecting humans in subtle, invisible ways that science has yet to detect? The implications of understanding consciousness are profound. If we could fully grasp its nature, it might illuminate the workings of the mind, the origins of creativity, and the roots of morality. It could reshape medicine, artificial intelligence, and even our sense of identity. Yet the closer we look, the more questions arise. How do memories, sensations, and emotions coalesce into the seamless continuity we call the self? Why does a particular pattern of neural activity produce the experience of redness, or the taste of chocolate, or the awareness of one's own existence? Even in our most intimate moments of reflection, watching a sunset, listening to music, feeling the presence of another, we confront consciousness in all its mystery. It is at once personal and universal, immediate and ineffable, a phenomenon that defines what it means to be human while remaining largely beyond our grasp. Each thought, sensation, and perception is a testament to the remarkable complexity of life, a reminder that the mind is not merely a vessel for information, but a living, dynamic experience that science continues to explore. And so, as we sit quietly, observing our own awareness, we are faced with the ultimate question: what is consciousness, and how does it arise from the matter of the brain to create the vivid, mysterious reality we inhabit? Could there be aspects of mind yet undiscovered, layers of perception that extend beyond biology, or even connections between individuals that transcend space and time? For now, consciousness remains an enigma, a silent, pervasive presence that shapes every human moment while leaving its deepest secrets hidden, inviting us to wonder at the nature of our own awareness and the vast possibilities that lie beyond our understanding. Beneath the dense canopies of African forests, across the rolling savannas, and buried deep within layers of rock that have endured for millions of years, traces of our past lie hidden, silent witnesses to a story that is far from complete. The fossil record, a mosaic of bones and impressions, has revealed fragments of human evolution. Australopithecus, Homo habilis, Homo erectus. Yet, between these known species, tantalizing gaps persist, gaps that scientists have long sought to fill with the elusive entity often called the missing link. This figure represents more than a single fossil. It is the bridge between ancient ancestors and modern humans, a symbol of the questions that remain about how we came to be. The search for the missing link is a story that stretches back centuries. In the 19th century, following Darwin's groundbreaking work on evolution, scientists scoured continents in search of evidence that could illuminate the gradual transformation from primates to humans. Fossils, such as the Neanderthals, discovered in the mid-1800s in Europe, and later Homo erectus in Java and China, began to sketch an outline of our evolutionary history. Yet despite these remarkable finds, the gaps between species remained conspicuous. Each new discovery answered some questions but raised many more. Could there have been branches of human evolution that never left clear traces? Might entire populations of hominins have thrived and vanished without leaving fossils to mark their existence? The mystery deepens when we consider the anomalies within the fossil record. Certain specimens, such as the enigmatic Homo floresiensis, discovered on the Indonesian island of Flores, defy expectations. These small-statured humans, existing as recently as 50,000 years ago, seem to overlap chronologically with modern Homo sapiens, yet exhibit features that recall much earlier species. Similarly, fossils unearthed in Morocco, dated to roughly 300,000 years ago, challenge previous timelines of brain development and anatomical evolution. What do these anomalies reveal about the complexity of human evolution? Are we witnessing isolated evolutionary experiments, or evidence of a far more intricate web of species interacting, migrating, and adapting than traditional linear models suggest? Beyond the bones themselves, the missing link has stirred philosophical and speculative inquiry. Could there be populations whose existence has left no fossilized record at all, their DNA diluted or erased by time? Genetic studies have revealed that modern humans carry traces of interbreeding with Neanderthals and Denisovans, hinting at encounters that once seemed improbable. Yet gaps remain. Entire lineages, perhaps entire species, may have disappeared without a trace, leaving only subtle genetic echoes. Might there have been other hominins, hidden in the shadows of deep forests or isolated valleys, whose existence could radically reshape our understanding of human ancestry? Environmental factors add another layer to the puzzle. Climate shifts, volcanic eruptions, and rising or falling sea levels would have shaped migration, survival, and extinction patterns. Fossil discoveries are often serendipitous, preserved in caves or sediment layers where conditions were just right. Vast regions of the planet remain unexplored or inaccessible. Millions of years of life have left no record in the places we have yet to examine. Could the true missing link still lie undiscovered, waiting beneath layers of earth, frozen tundra, or dense jungle? The missing link also challenges our notions of identity. It asks us to reconsider what it means to be human. Are we the inevitable result of a smooth, linear progression, or the product of a complex, branching tree filled with experiments, dead ends, and convergences? How did cognition, language, culture, and social behavior emerge within these ancient populations? Did the missing link possess rudimentary symbolic thought, the first inklings of art or ritual, or were such traits scattered among multiple hominin species in ways that leave only faint traces today? Even as technology advances, through imaging, DNA analysis, and new excavation methods, the gaps remain. Each discovery seems to open new questions: unusual skull shapes, teeth that defy expectation, skeletal structures that suggest adaptation to unknown environments. For every piece of evidence, the record offers tantalizing hints, but never the full story. The missing link is as much a metaphor as a fossil. It embodies the unknown, the space between what we have discovered and what the Earth has yet to reveal. As we peer into caves, sift through sediment, and analyze ancient DNA, we are reminded that the story of human evolution is far from complete. The missing link is more than a scientific curiosity. It is a mirror reflecting our curiosity about ourselves, our origins, and the paths that life can take across eons. What other forms of early humans have existed, thrived, and vanished without leaving a mark? How many secrets are still buried, waiting to challenge our understanding of who we are and how we came to walk upright on this planet? In the quiet of ancient landscapes, where the past has been layered in stone and soil, the missing link waits, silent, elusive, and unresolved. a mystery that invites us to imagine the unseen chapters of human history and to wonder what revelations still lie beneath the surface, hidden from view, but no less real. In a quiet room of the Baghdad Rare Book and Manuscript Library at Yale University, a fragile codex rests under glass, its pages yellowed with age and filled with symbols that no one has ever definitively deciphered. This is the Voynich Manuscript, a mysterious book that has defied cryptographers, linguists, historians, and code breakers for more than a century. Each page is a labyrinth of swirling, unknown script accompanied by strange illustrations of plants that do not exist, celestial diagrams that seem to chart alien skies, and enigmatic human figures engaged in inexplicable rituals. To open its pages is to step into a world both familiar and utterly alien, where the boundaries between science, art, and the unknown dissolve into a puzzle that has resisted understanding. Carbon dating places the manuscript in the early 15th century, around 1404 to 1438, yet its origins remain shrouded in mystery. It first surfaced in the early 20th century when it was purchased by the rare book dealer Wilfrid Voynich, whose name would become inseparable from the manuscript itself. Yet questions linger. Who wrote it, and why? Scholars have traced its provenance through European libraries, but every clue only deepens the enigma. Its illustrations suggest knowledge of herbal medicine, astronomy, and biology. Yet the plants and constellations it depicts appear imaginary or drawn from an unknown system of knowledge. Could it be the work of an eccentric scholar, a hidden society, or even an intelligence whose methods of recording knowledge are lost to history? The manuscript's text is perhaps its most perplexing feature. Written in an unknown script that has never been definitively decoded, it exhibits a structure reminiscent of natural language, complete with recurring patterns, word divisions, and grammatical rules that imply deliberate composition. Yet no cipher, linguistic analysis, or computational model has yielded a definitive reading. Could it be a sophisticated code meant to conceal knowledge, a lost language, or even a constructed linguistic experiment? Some propose it may be an elaborate hoax, yet the statistical complexity of the text suggests intention far beyond mere deception. The illustrations intensify the intrigue. Plants with no botanical counterparts, some resembling hybrid forms that exist nowhere else, fill the pages. Astronomical diagrams depict spheres, stars, and lunar phases arranged in ways that hint at celestial observations, yet do not correspond neatly to known systems. Human figures, often immersed in pools of water or performing cryptic gestures, evoke rituals whose purpose remains opaque. Could these images encode medicinal knowledge, alchemical processes, or philosophical systems now lost to time? Or do they represent a symbolic universe entirely separate from our own? Throughout its history, the Voynich Manuscript has attracted the attention of some of the most brilliant minds. During World War II, American and British cryptographers, including those trained at Bletchley Park, attempted to unravel its secrets, yet none succeeded. In recent decades, computational linguistics and AI have been applied to the text, revealing patterns and structures that continue to intrigue scholars. Still, no theory has achieved consensus. Does this suggest that the manuscript preserves a type of knowledge we are not yet capable of decoding, or that its meaning was never meant to be fully understood by human minds? Speculative theories abound. Some suggest it could be an early pharmacological reference, containing information on herbal remedies and medical practices of a forgotten culture. Others entertain the possibility of it being a coded alchemical manual, or even a treatise on cosmic or spiritual truths hidden from ordinary understanding. Fringe interpretations range from extraterrestrial authorship to mystical texts created for esoteric purposes. Each hypothesis, grounded or speculative, speaks to the manuscript's enduring ability to captivate and confound, reminding us that the human quest for knowledge often encounters boundaries that may never be crossed. What is certain is that the Voynich Manuscript occupies a unique place in human history, a tangible artifact that invites curiosity and wonder. Its pages whisper of a mind, or minds, that grappled with complexity, imagination, and perhaps secrecy, creating something that resists comprehension even centuries later. It challenges our assumptions about language, symbolism, and the limits of human knowledge, serving as a mirror that reflects both the vast potential of human creativity and the enduring mysteries that continue to elude us. And so, as scholars examine its text and study its peculiar illustrations, questions remain. Who wrote it, and for what purpose? What knowledge, real or imagined, does it contain, hidden beneath layers of unfamiliar script and surreal imagery? Could there be a key to understanding it waiting to be discovered, or is its true meaning destined to remain forever beyond our reach? For now, the Voynich Manuscript endures as an emblem of the unknown, a testament to the ingenuity of the human mind, and a silent, enigmatic challenge that continues to inspire wonder, curiosity, and profound speculation. Beneath the waves off the rocky coast of the Greek island of Antikythera, a centuries-old shipwreck lay hidden for nearly 2 millennia, silently guarding one of humanity's most astonishing technological enigmas. In 1901, sponge divers exploring the wreck stumbled upon corroded bronze fragments that, at first glance, seemed no more remarkable than the scattered relics of daily life from antiquity. Yet among the debris lay a device of extraordinary complexity: the Antikythera Mechanism, an ancient analog computer whose sophistication would not be replicated for over 1,000 years. Its discovery immediately raised questions that continue to intrigue and confound scientists, historians, and engineers alike. The mechanism itself is composed of a series of interlocking gears, finely crafted and meticulously arranged to track astronomical cycles. With dials and inscriptions etched in Greek, it could predict the movements of the sun, moon, and perhaps even the planets. It could forecast eclipses and, as some studies suggest, align with the calendars of the Olympic Games. The precision required for such a device indicates a mastery of mechanical engineering and astronomy that seems astonishing for the Hellenistic world, circa 150 to 100 BC. How could ancient artisans, without modern tools or electricity, have conceived, calculated, and executed such an intricate mechanism? Early examinations puzzled researchers. The corrosion and fragmentary nature of the device obscured its purpose, and only with the advent of X-ray imaging and 3D modeling in the late 20th and early 21st centuries did the true complexity begin to emerge. Layers of interlocking gears, some hidden behind others, revealed a technology far ahead of its time. The Antikythera Mechanism was not merely a calendar or an astronomical calculator. It was a sophisticated analog computer, capable of modeling celestial motion with remarkable accuracy. Yet questions remain. Who created it, and for what purpose? How widespread was this knowledge, and why does no other device of comparable complexity appear in the historical record for over a millennium? Scholars have traced the mechanism's intellectual heritage to the Hellenistic tradition of science and astronomy. Figures such as Archimedes, Hipparchus, and Posidonius are often invoked as possible sources of the theoretical foundations underlying its design. Ancient texts hint at planetariums and mechanical devices that could model celestial cycles, yet none survive with the Antikythera Mechanism's precision. Was it a unique artifact, a singular masterpiece of an exceptional mind, or part of a broader, now lost tradition of mechanical astronomy? The fragments themselves pose a riddle. Inscribed markings describe astronomical phenomena, months, and possibly zodiac signs, yet parts of the device remain missing, leaving its full capabilities open to speculation. Could it have tracked the positions of planets beyond Saturn, whose discovery would come much later? Was it intended as a tool for scholars, a teaching instrument, or perhaps even a device for divination, merging science with the mystical traditions of the time? Each possibility stretches our understanding of the sophistication and ambition of ancient civilizations. Some speculative theories suggest the Antikythera Mechanism represents knowledge that has been lost to time, a technological leap that vanished with the decline of Hellenistic society. Could similar devices have been widespread among seafaring civilizations, only to disappear during periods of political upheaval or cultural transition? Others propose that it may have been the product of collaboration among astronomers, mathematicians, and artisans, a testament to a society capable of combining intellectual insight with mechanical ingenuity. The absence of comparable devices leaves us to ponder whether we have merely glimpsed the tip of a long-lost technological tradition. The Antikythera Mechanism continues to challenge assumptions about the capabilities of ancient engineers. Its precision gears prefigure developments that would not appear again until the European Renaissance, over 1,000 years later, in the work of astronomical clocks and mechanical computers. How did a civilization without industrial tools produce such intricate mechanisms? What does this say about the intellectual climate of the Hellenistic Mediterranean, where scholarship, mathematics, and observation coalesced into practical invention? As modern technology allows researchers to reconstruct its functions and model its mechanics, the Antikythera Mechanism remains both a window into antiquity and a mirror reflecting our own fascination with the unknown. It embodies the tension between what we can observe and what remains hidden, the gaps between human creativity and the evidence left behind. Ultimately, the Antikythera Mechanism invites us to consider not only the ingenuity of the past, but the mysteries that remain buried, awaiting discovery. How many other devices, ideas, or insights lie lost beneath the soil or sea, beyond the reach of our eyes and tools? What other technological marvels did the ancient world conceive that we have yet to encounter? As we trace the delicate gears and inscrutable inscriptions, we are reminded that history often whispers its secrets slowly, and that some of the most profound mysteries may be found in the quiet spaces between what we know and what has yet to be revealed. In the arid sands near modern-day Baghdad, Iraq, an unassuming clay jar rests quietly in the shadows of history, a relic whose purpose has puzzled archaeologists for nearly a century. Unearthed in 1938 during excavations of the Parthian ruins at Kujut Rabu, this artifact, later dubbed the Baghdad Battery, consists of a clay vessel enclosing a copper cylinder within which sits an iron rod. Sealed with bitumen, the jar seems innocuous, yet its configuration hints at a function far beyond mere storage. Could this be an ancient electrical device, a technological enigma predating anything comparable by thousands of years? The artifact dates to somewhere between 250 BC and AD 250, a period when Mesopotamia was a crucible of cultural and scientific exchange. Scholars have debated its purpose since its discovery. Some suggest it was a simple storage container, or perhaps a vessel for sacred scrolls or relics. Yet experiments have demonstrated that, when filled with an acidic liquid, such as vinegar or lemon juice, the combination of copper and iron could generate a small electrical current. If this is true, then the Baghdad Battery could represent one of the earliest known attempts at harnessing electricity. But for what purpose? Historical records from the region offer little clarity. Parthian and earlier Mesopotamian cultures excelled in metallurgy, astronomy, and intricate craftsmanship, yet there is no textual evidence describing electrical devices. Could the battery have been used for electroplating, a process that requires a low current to deposit metal onto objects, or for medicinal purposes, perhaps intended to stimulate the body or provide a therapeutic effect? Or might it have been a ceremonial object, its function symbolic rather than practical, its current generation incidental rather than intentional? skeptics caution against reading too much into a single artifact. The jar could easily have been part of mundane domestic life, its potential to generate electricity purely coincidental. Yet the precision with which the copper and iron components were fitted and the protective bitumen seal suggest intentionality. The possibility that an ancient civilization could have understood, even partially, the principles of electrochemistry raises profound questions about the transmission of knowledge through history. Was this an isolated experiment, a fleeting insight into natural forces, or evidence of a sophisticated technological tradition that has otherwise vanished from the historical record? The Baghdad Battery is not unique in concept. Several similar jars have been discovered in the same region, hinting at the possibility of a series of such devices rather than a singular curiosity. If true, this could indicate practical applications known to craftsmen and priests of the time, yet lost to us in the millennia that followed. Could these jars have been used to produce small sparks for ritualistic purposes, or to chemically treat metals, creating gilded or silvered surfaces with an early form of electroplating? The lack of definitive evidence leaves all such possibilities tantalizingly unresolved. Speculative theories abound, bridging the boundary between archaeology and imagination. Some propose the jars were part of alchemical experiments, attempts to transmute or manipulate matter using forces only partially understood. Others suggest that the jars might have been used for religious or magical rituals, with the concept of invisible forces like electricity woven into the spiritual practices of the time. While there is no conclusive proof for any of these interpretations, the very existence of the artifact challenges conventional timelines of technological development. Experimental archaeology has attempted to test the Baghdad Battery. When assembled with an acidic solution, the device produces a small, measurable voltage. This demonstrates that ancient people could have intentionally, or perhaps serendipitously, created a simple electrochemical cell. But why? Was this knowledge fleeting, confined to a handful of practitioners, or more widely understood than the archaeological record allows? The artifact suggests a level of curiosity and experimentation that rivals much later discoveries in human history. The Baghdad Battery serves as a reminder that human ingenuity often precedes our expectations. It challenges assumptions about the capabilities of ancient civilizations and invites us to reconsider the boundaries between science, craft, and mystery. Could there have been lost workshops where electricity was understood in practical terms? Or was this merely a fleeting spark of experimentation that vanished with time? As scholars continue to debate its purpose, the Baghdad Battery remains a symbol of the unknown, a silent artifact that invites both awe and inquiry. Its humble clay exterior conceals the possibility of an ancient mind attempting to harness invisible forces, a tantalizing whisper from the past that reminds us how much of human history remains hidden, waiting for discovery. What other inventions or insights might lie buried beneath the sands, lost to time, or obscured by the gaps in our understanding? For now, the Baghdad Battery endures as a quiet enigma, its true function and the brilliance of its creators still a mystery. Stretching across the arid plains of southern Peru, beneath a sun that casts harsh shadows on a landscape of ochre and rust, lie the Nazca Lines, vast, enigmatic geoglyphs etched into the desert floor. From the ground, they appear as faint scratches in the sand, barely distinguishable from the surrounding terrain. Yet from the air, they reveal themselves in astonishing scale and precision, giant figures of animals, plants, and abstract shapes, some hundreds of meters long, stretching across the desert like messages from a distant past. The sheer magnitude of these creations immediately sparks wonder, compelling us to ask, why were they made, and by whom? Dating back roughly to between 500 BC and AD 500, the Nazca Lines were created by the Nazca culture. Yet even the most meticulous archaeological studies provide only partial answers. Stripping away the reddish-brown stones that cover the desert surface revealed lighter soil beneath, a simple yet effective technique that allowed the lines to endure centuries of wind and occasional rain. The precision and scope of the designs suggest careful planning and an intimate knowledge of geometry, perspective, and the desert's shifting terrain. But what motivated this extraordinary effort, spanning hundreds of square kilometers in a region where survival was a constant challenge? Some theories point to practical explanations. The lines may have served as astronomical markers, aligning with solstices and equinoxes, functioning as a massive calendar etched upon the Earth itself. Others propose that they were connected to water rituals, guiding the heavens' favor toward the arid land, summoning life-giving rains to sustain crops. Yet while these interpretations hold some merit, they leave many questions unanswered. Why choose such enormous scale, visible primarily from the sky, when ground-level observation would suffice? It is here that the mystery deepens. The Nazca people had no known capability for flight, and yet the designs suggest a perspective only achievable from above. Could the geoglyphs have been intended for the gods, a visual language decipherable only from the heavens? Or were they perhaps part of ceremonial pathways, guiding ritual processions across the desert, creating a sacred theater of movement and geometry? Some researchers have even speculated that the lines could encode astronomical or cosmological knowledge, a symbolic map of the stars projected onto the land. Yet these interpretations remain inconclusive. Beyond the practical, there is an element of awe inherent in the figures themselves. Monkeys with spiraling tails, hummingbirds hovering in midair, spiders with meticulously crafted legs, and geometric trapezoids and lines stretching for kilometers, all crafted with such consistency that each can be recognized instantly despite their monumental scale. How did a society without aerial technology or advanced surveying tools achieve such precision over vast distances? The techniques remain largely speculative, involving simple measuring ropes, wooden stakes, and a keen understanding of proportion. Yet the perfection achieved continues to astonish modern engineers and artists alike. The durability of the Nazca Lines adds another layer to their intrigue. Protected by the region's dry climate, they have survived for centuries, enduring natural erosion and human activity. Yet their fragile simplicity, a removal of surface stones rather than construction with lasting materials, suggests a deep respect for the land, a knowledge of natural preservation, or perhaps an understanding that the line's purpose was not permanent in human terms, but eternal in a spiritual or symbolic sense. Speculative theories stretch even further, inviting interpretations that blend science with imagination. Some suggest the lines were markers for otherworldly visitors, an ancient attempt to communicate with entities beyond human comprehension. Others propose a ritualistic purpose tied to fertility, death, or cosmology, a sacred dialogue between humanity and the forces governing life in the desert. While evidence for these theories is limited, they underscore the enduring fascination these geoglyphs inspire, a tension between what is known and what may never be fully understood. Today, the Nazca Lines continue to baffle and inspire, their secrets layered beneath millennia of sand and wind. Archaeologists, anthropologists, and mathematicians have pieced together partial explanations, yet the true purpose, methods, and meaning remain elusive. Each flight over the desert reveals new patterns, new intersections, new spirals, reminding us that some mysteries persist not because of the absence of inquiry, but because their answers exist in a realm just beyond our reach. The Nazca Lines invite reflection on the ingenuity, creativity, and devotion of a civilization long past, and they challenge our assumptions about human ambition in a harsh and unforgiving landscape. What drove the Nazca people to etch these monumental images into the desert? And why did they choose such scale and form? How much of their knowledge has been lost to time, carried away on the desert winds? As we gaze across the plains, following the lines that stretch to the horizon, We are left with the humbling realization that some messages from the past remain deliberately, beautifully, inscrutable, waiting for the observer to ponder, to wonder, and perhaps to feel a faint echo of connection across thousands of years. Pinned to the walls of the Topkapi Palace in Istanbul, Turkey, a delicate fragment of parchment stretches before the viewer. A map that seems, at first glance, unremarkable. Yet the Piri Reis Map, crafted in 1513 by the Ottoman admiral and cartographer Piri Reis, is anything but ordinary. Its meticulously drawn coastlines, intricate annotations, and bold lines of longitude and latitude reveal an astonishing understanding of geography for the early 16th century. At a time when the New World was still being charted, this map presents an accurate depiction of the western coasts of Europe and Africa, the eastern shores of South America, and, tantalizingly, hints of lands far to the south that would later spark debate and speculation. Antarctica, seemingly drawn centuries before its official discovery. Piri Reis himself left notes along the margins, acknowledging the sources he used: older maps, charts of Portuguese explorers, and accounts from sailors who had traversed distant oceans. Yet the precision of certain features, particularly the southern continents, defies explanation. How could a map created in 1513 depict coastlines that would only be officially surveyed hundreds of years later? Was this the result of careful compilation, forgotten voyages, or something more mysterious? The map is fragmentary, surviving today only as a portion of a once larger chart. Even in its incomplete state, however, it has challenged historians and geographers for generations. The depiction of South America aligns astonishingly well with modern measurements, yet some of the southernmost coastlines appear to show a landmass beneath the icy waters, Antarctica, free of ice, suggesting either incredible conjecture or knowledge lost to time. Could Piri Reis have had access to ancient maps, preserved through the centuries, that recorded a world long before our modern exploration? If so, who created these earlier charts, and by what means did they measure continents with such remarkable accuracy? Mainstream scholarship attributes the map's precision to the aggregation of known navigational data and cartographic traditions. The Portuguese and Spanish were active explorers, their charts passed between courts and navigators. Piri Reis, as a skilled admiral and cartographer, may have synthesized this information with exceptional skill. Yet, certain details defy conventional explanation. The southern continent is drawn with a level of detail inconsistent with the technology of the era. Even more perplexing is the apparent knowledge of longitude, a concept not formally measurable at the time without precise instruments. How did Piri Reis, or his sources, translate oral accounts and fragmented charts into coordinates that align with modern geography? Speculative theories have abounded for decades. Some suggest that the map preserves fragments of ancient knowledge, perhaps derived from civilizations long lost to history. Could remnants of the Phoenicians, Egyptians, or other seafaring cultures have influenced the depiction of distant lands? Others propose that the map is evidence of contact with unknown visitors, a mysterious transmission of knowledge that predates recorded history. While such ideas remain controversial, they underscore the enigma. The Piri Reis Map is far more than a simple navigational tool. It is a puzzle whose pieces stretch across time and imagination. Adding to the intrigue are the annotations Piri Reis included along the margins, written in a mix of personal notes and translations of older texts. They describe lands and peoples in astonishing detail, mentioning not only geography but resources, climatic conditions, and cultural practices. These observations suggest that the map was not merely theoretical, it was intended as a practical guide for navigators. Yet it also hints at information that seems almost prophetic, particularly the unexplored southern regions. How much of this knowledge was accurate, and how much was interpretation or educated guesswork? The Piri Reis Map remains a nexus of history, science, and mystery. It invites us to reconsider the boundaries of what was possible in early 16th century cartography. Could there have been ancient voyages across the oceans whose records survived only in fragments like this map? Was Piri Reis preserving a long-lost legacy, combining the known and the unknown into a coherent whole? Or is it simply a remarkable demonstration of human intuition, a blend of careful observation, logical inference, and a touch of creative imagination? Today, as scholars and enthusiasts study the fragile parchment, they are struck by the layers of uncertainty it embodies. Each line, each curve, each marginal note beckons us to question the flow of human knowledge. How did early explorers perceive the world? How much have we truly lost in the silent passages of time? And what other mysteries, like the Piri Reis Map, might lie hidden in archives, waiting to reveal that history is not always linear, and that the past may still whisper secrets we have yet to understand? The Piri Reis Map stands as a testament to curiosity and the human drive to chart the unknown. It challenges us to peer beyond the visible, to reconcile what is recorded with what may have been lost, and to wonder whether the map we hold in our hands is only the surface of a far deeper, more intricate story, one that continues to unfold as we search for answers across centuries and continents.